How ace was that? How ace was that introduction by Mind Warped for Sleeping Warrior? Now, I know that he's had that for a little while there. Tony, are you there? Because that introduction is awesome.
Yeah, it was a shame it wasn't full screen, Ranty. You had it on 3/4 of a screen, but other than that, it was fine.
Never mind. I have got the most important part playing behind. Unfortunately, I think I've contrasted it with a black T-shirt, so I'm sort of in those flames. But that doesn't really matter, does it? We can get past that for the time being. So, how are you, Tony? We haven't had much of an interaction recently. Tell us all about it.
I'd forgotten who you were, Ranty. I'd seen your name floating around a couple of times, and I couldn't actually remember what you looked like. It's been that long.
How can you forget me? We've known each other for what? How long now? Must be what?
It's those chisel good looks, Ranty. You blend in with all the other superstars in Flat Earth.
What can I say? What can I say? So we've got a title for this round table. Atmospheric pressure does not exist. Okay, that's an interesting title, and it grabbed my attention. I'm sure there's a lot of people that would like to know. The most important part, is this anything to do with Spurs chemo?
No, I don't think so. I'm not sure what Spurs' current position is. To be honest, I've never really been sure what his position was on this pressure point anyway, because he couldn't really formulate it into words that made me understand his point, and he's still probably getting there. So I don't think it is. It might have some elements to it that are similar, but I don't believe it is. So no, I don't. I'm going to say a tentative no, but I might actually be wrong. So I'm going to say actually I don't really know.
Okay. Right, so we do have a presentation ready to go. We're hoping to get the Rumpus in, but if we can't get the Rumpus in, we do have somebody else on standby. I don't know if you've spoken to him. We were talking about it before.
Gently's channel. I'm aware of him. I've never heard him. I don't know anything about him. He's just a new cat on the scene as far as I can see. And well, I'm hoping Rumpus turns up. Actually, I don't know what's happened to Rumpus. He knew the time. He's had the pre-disclosure, but he's not received the file because he's not been online for some reason. So it's unusual for Rumpus. So I hope he's all well and good, and I hope he's just forgotten and there's no harm come to him or whatever. But on the other hand, I wish you were here, Rumpus, because you're. I want to hear what you got to say. I want to hear you account for your so-called science.
Well, he's everybody's favourite Glober to hate, isn't he, the Rumpus? Let's be honest. But he does get stuck in, and he comes on the shows, and he's got a point. And I say when he's got a point, when he thinks he has a point, he sticks to it. And I'm sure he's just got an equally good Glober point against whatever presentation you're gonna do this evening. But let's get to it. I'm interested to see what you've got.
Did he confirm that he was going to be here and present at the right time?
Not 100%, but like I said, if he doesn't show, we can bring in Gently's channel. So that will be like you say, a new cat on the block. So if he doesn't show, then we've got somebody else. What can I say? They may be able to put up a better performance. Who knows?
Cool. So okay. Should we go, or should we wait for?
No. Fire away. I'd rather see your presentation. If he's not around, so be it. We'll bring in Gently's channel afterwards. But if you want to start sharing your screens, I'll get you on.
Okay. So share. I do need sounds. Share screens and sounds. Yes.
And shout out to everybody. Just one thing. Shout out to everybody in the channel, in the chat. And Nathan Oakley, thank you for sending all your channel people across. And I do appreciate you doing your show a little bit earlier as well. It was very, very good of you to do that. Thank you. Right. Okay. So you're now presenting.
What I want to do, Ranty, just before we go any further, I'm just going to play a music file in the background. Just see does the sound come through.
Well, go on.
Okay. Hang on, it's coming. It's firing up the mechanical drive, hang on. Do you hear that?
It's very low.
Okay, I can turn it up, hang on.
No, don't hear
it. You don't hear that?
No, afraid not, mate.
Let me work out why.
So, a few shout outs whilst you're figuring out that. We've got Gleam in chat, Spurs Chemo. Nice to see Spurs in. Who else have we got in? John Watson. Juan Carlos, Bible Literalist. Subscribe today for Bible Literalist if you want to see her take on stuff. She has a great channel. Arwen's in the chat as well. Subscribe over there. Go and watch his early bird show, 1 p.m. To 2 p.m. BST. Go ahead over there. Who else do we have in? We've got Paige in. Nathan Oakley, I'm sure you all know Nathan. Yeah, we've got a few people in. Come on, Tony, have you got it sorted out yet?
I think so. Just tell me, can you hear it?
I can't. I'm sorry.
You can't?
No.
I'm going to need this. I might have to dispense with it. It's okay. If I can't get it... Look, on mine, it says it's going through. You should be...
Do you want to send me the file? Maybe I can play it.
Yeah, I'll send you the file. I don't know why that's not working. Blame Nathan. Alright, so where is this file now? It's gone to there, hasn't it?
Yeah. Do. We're all waiting in suspense.
That's okay. It's called Hillbilly Blue Balls.
Oh, and bearing in mind, I mean, because I would imagine by the end of this show, or by the end of a couple of days, there's going to be at least 1,000 people who've seen this show. Subscribe to Sleeping Warrior. He's just behind me on subscribers. He's been catching me for the past couple of months. I think he's only a couple of hundred short, so, let's see if we can get him up to bypassing me, because he has put a lot of work in recently. He deserves your subscribing.
Yeah, and can I just say that I was here before Ranty. It's not fair that Ranty's actually got more subs than me. I should have more because I've been here longer, like at least 12 months longer. Right, Ranty, you've got the file, so just be ready for that when I'm ready, because that'll be coming up shortly.
Okay, let me get that up and download it. So let's get the. This is all very on the hop. Can you stop share? Oh, hang on, no, it's fine. Keep sharing your screen, it's all good. I just need to download this, so there we go. Download.
Right, I'm not able to do this full screen because for some reason it's on one monitor, but when it does full screen, it's flicking across to my other monitor, and I don't know why it's doing that. It's just being a little bit idiot.
Okay, so do you want me to play this video right now?
No, just be ready to play it when I'm playing it. It comes up on the 4th or the 5th slide.
Okay, no problem. Right, I'm going to transition you across. You're ready to go. Hit it.
Alright, so atmospheric pressure does not exist. This has come about because the gas pressure next to a vacuum argument. Ranty, do you want to go on mute?
I am on mute, mate.
Oh, right, okay. The gas pressure argument next to the vacuum of space can't exist on the model. I've demonstrated what happens when you have gas pressure next to a vacuum on my channel, and we know that it immediately bursts into the vacuum. That's what the science tells us it actually does. So they say, well, gas pressure is not the same as the Earth. The Earth is a special pleadings case. It's a special pleadings set of rules. Physics doesn't apply to the Earth because the Earth's got its own set of physics, apparently. And they have a special pleadings fallacy. So they tell us that it's not actually gas pressure, it's atmospheric pressure. And the fact that this definition exists tells everybody that their story, they realise that this doesn't work on their model, and they have to have it like this because they need a correction, because gas pressure doesn't do what they tell us it does. So I put a video up recently. Atmospheric pressure is a total fraud. As of writing now, as of doing this interview or hangout right now, it's had 1,800 views. It's on my channel. It's one of my more recent videos. And I'll just bring this across so you can see it. In this video, the fraud of the atmospheric pressure, I've pinned a comment from this well-known troll. He's on a sock account here. But in this conversation, you should have a read of this for homework, background homework. He's consistently and continuously citing that gas pressure is not the standard, it's atmospheric pressure. And he's not on his own. Everybody does it on their side. It's almost as if they're reading off of the same hymn sheet. So if they're all saying it, then obviously that's enough for me to say, well, perhaps this is their position. Even if I disagree with it, I'm going to cite their position. I thought Rumpus would be here by now to be able to just to confirm all this, but for whatever reason he's not. So do check out the thread. At some point I opened the thread because I have everything that I want. Now what I'm going to do, atmospheric pressure. So gas pressure pushes out against the surface of the container in all directions evenly. That's Pascal's law. Now it's pushing out in all directions evenly, right? Nathan says frequently that you can't have gas pressure without a container. The sky's not a vacuum, and he's right. The sky is not a vacuum. The gas pressure is supposed to be pushing out in all directions because that's the way that gas pressure behaves. But it doesn't seem to do that in the atmosphere. Now that tells me one of two things is true. Either we're contained, and that's why it's not doing it, or gravity exists. It's one or the other. Now, even if gravity does exist, that's the other thing. Let me just clarify my position. For the purposes of this hangout, I just concede that gravity is a force because I don't want to get bogged down into the arguing over whether gravity is a force or not. We all know the current position. It's Einsteinian gravity. It's an effect of the curvature of space-time caused by the uneven distribution of mass. And they've got to formulate all of their explanations based on space-time. But for the purposes of this hangout, I'm prepared to just dispense with it and just concede it for this hangout and only this hangout because I don't want to dwell on it. I don't want to distract from the main point. The starting position is not that the earth pressure is pushing down the way that this picture depicts. The starting position is that we have gas pressure and it pushes out in all directions. That's the starting position. So the starting position on the atmospheric pressure argument is the inverse of what it actually is doing in real world. Not on their model, in real world, because we know that pressure pushes out in all directions evenly against the surfaces of the container. Well, the Earth's the container, it pushes out in all directions evenly. That means that once the particles hit the Earth, which we know it must have done because we've got pressure, all directions are space, and it pushes out in all directions evenly. That's what it says. But they start with this definition that states that actually it's the weight of the atmosphere pushing down. And they indicate it with arrows. That's literally the opposing arguments. They can't redefine something and say it's the opposite just because it suits their model. That's complete horseshit. They've got to define it the way that it is, because gas pressure is pushing out in all directions. This nonsense that they've got on screen is completely the inverse, and it's only in their model where this applies. Because in real world, gas pressure doesn't do what they say it does. Gas pressure does what we can demonstrate that it does on a smaller scale in a lab, time and time again. So for those that are not aware, not familiar, a couple of weeks back, I cited this. I made this video up, and what it shows is that this is gas pressure. It's coloured so that we can see it, and this is a vacuum. Doesn't matter how much of a vacuum, it's just lower pressure than this. There's a tap, it separates the two. When you open the tap, it fills the available volume. That's what the science tells us, and that's also what we can demonstrate on a smaller scale. The minute the tap's opened, it immediately fills it. It doesn't gradually do it. It doesn't peel off just the top layer of the gas pressure. All of it immediately goes. Now look at the volume. You can see that the colour changes slightly. It goes from a deep colour to a pale shade. And that's because the total volume of the whole setup isn't enough for this to disperse all of it into it. If this was the infinite vacuum of space that didn't have a container, this would be completely empty. There would be nothing in it. Because of the differential. That's what pressure is. It's the differential. And pressure, of course, is a force. So, with that being said, we know the position with gas pressure. I'm not going to dwell too much onto this because we know it. All the particles are colliding with the inside of the walls of its container. That's where we get the pressure from. On this picture, there's 14 molecules, and they're zipping around at high velocity in all directions, and it's non-uniform. There's no pattern to it. It's random, and that's where we get the pressure. So all 14 molecules are bouncing around in crazy angles all at once, all hitting each other, hitting the walls. That's what gives us the pressure. And obviously in this one, the pressure is shown by the arrow. The arrow is the direction and the magnitude of the pressure. That's where the pressure is coming to and from. It's coming from the container and it's going towards the opposing angle that it's been hit at. That's where we get the pressure from. We all get that. But that doesn't work on the sphere, on the ball. So that's why they've got to have this alternative definition. On gas pressure, we know that the pressure is the force that the gas exerts on the walls of its container. It's literally everywhere, this. You've got to have a container. That's our argument. Then they redefine it and they say, well, actually, it's not really gas pressure that we have. It's actually atmospheric pressure. Blue Marble Science has recently done a video today or yesterday, maybe the day before, and he cites this Indiana University webpage, and I'm going to cite it as well, just because I actually agree with what he says in the sense that he's citing from a credible reference, and that's what we need to be doing. We need to be citing definitions from credible citations from universities. This is the standard that we should be using. We shouldn't be using blogs from Forbes or from Quora, because they're just people expressing their own personal views or beliefs. Sometimes they might be right, other times they're not right, and it's contentious, and they don't tell you it's contentious. And well, we know that most of this topic is contentious, so let's cite properly from credible citation. And for that reason, I agree. Hillbilly Blue Balls has cited Indiana University. I'm going to cite from it too. And it just basically says the same thing. The gas pressure is caused by the collisions on the insides of the containers. Okay, Hillbilly Blue Balls. I'm going to play a small clip, or Ranty's going to play a small clip from Hillbilly Blue Balls in a sec. The definition of atmospheric pressure is the weight of the air above you in a column pushing down on you because of the weight. Now, there's a density gradient, and it obviously gets more dense at the bottom, but it's the definition is the bit I want to focus on. It's atmospheric pressure equals weight over unit area. So the weight of the overlying air over the unit area. Ranty, do you want to play the clip from Hillbilly Blue Balls and let's hear what he says about it?
Well, again, according to Indiana University, atmospheric pressure is now the pressure on the outside of the balloon. What does that depend on? Well, not an air compressor, that's for sure. In fact, what it depends on is nothing more than the acceleration of gravity. Atmospheric pressure is simply the weight of the air above any point. You know, we've gone through this and we've shown the derivation of the barometric equation. You've seen this before. All that is required is the acceleration of gravity. So to have one of those things pressurized, to have pressurized gas in a sealed container, you need something like that. To have atmospheric pressure, all you need is one of those things.
Now, I actually wish I could have heard that. I couldn't hear that, so I can't actually remember what he says. But the gist of what he says is that atmospheric pressure is the weight of the atmosphere pushing down, or words to that effect. I couldn't hear what he said then, so I'm having to remember it. And that's the bit I want to focus on. I want to focus on the meaning of them words. Ranty, stick yourself on mute, mate, because you're dead loud in the background. I want to focus on on the words, because words have meaning, right? When it says gravity is not a force, it doesn't mean it is a force. It means it's not a force. When something's hot, it doesn't mean that it's cold. It doesn't mean that it's lukewarm, or it doesn't mean that it's a gradient. It means it's hot. So when it says atmospheric pressure is weight over unit area, that's what it means. So what we need to do is we need to have a definition, because definitions are important. So when we see atmospheric pressure equals weight over area, well, weight in physics is defined as mass times the acceleration of gravity. Or like I said, gravity is not an acceleration, it's an effect. But for the purposes of this conversation, I'm just going to concede it. The bit I want to focus on is the other part of the equation, the mass bit. Because if let's just give them the gravity, they need the mass. If they haven't got mass, then they haven't got weight. If they haven't got weight, then they haven't got atmospheric pressure, because words have got meanings. So what's mass? This is $1 million question. Now, in Nathan's show, we have this question come up periodically. Mass is one of those words that has the messiest interpretation or the messiest definition ever, because there's no consistency to it. You can go to 10 websites and get similar but different meanings from all of them. There should be a unified, singular definition for it, and there isn't. There's an equivocation, of course. There is the resistance of a body's desire to move, inertia, or it's the quantity of matter in a volume or in an object. But it's silly. We need to know what mass is. We know what mass really means day to day, colloquially. But in physics, the minutiae of words is important. So we need to ask ourselves, well, for them to have atmospheric pressure, they need to have mass and they need to have gravity. Let's give them gravity, but for this conversation. But how are they getting the mass? So let's consider the particles. There's 14 particles inside this container. The argument is that this mass has weight. If we have little g, then the weight in there in newtons is plus the gravity. The weight in there is measured in whatever, multiplied by the speed of gravity gives you an answer in newtons. Well, how do you measure this? So what you've got to do is you've got to get like a balloon or something. You've got to get some kind of container, and you've got to capture all of the molecules that are inside the container, and then you've got to measure it, and then you've got to exhaust it and make it into a vacuum, and then measure it again, and then take one from the other. The problem is, the definition of mass isn't a collection of material. The definition of mass is mass, right? So is it a collection of 14 molecules inside a balloon, or is it the molecule itself for the mass? So then that poses the question, well, they need mass. My position in this discussion is that this is masses, and there's 14 masses in here. So that's not mass. For them to have mass, they need a molecule, because that would be the definition of mass. This is plural. This is masses. So in the definition, it doesn't say masses, it says mass. It doesn't say masses. So when we have these collisions and all these 14 particles in here, you've got to put them in a container to get this collective mass. But mass isn't a collective, it's a singular. So really, you've only got one mass. Now, the reason why this is important is because even if they've got gravity, which I'm just conceding for shits and giggles, but if they've got gravity, it's only working on each of these individual molecules one at a time. It isn't a collection of all 14 molecules giving you a cumulative mass. And we know that because words have got meaning. And I'm now going to try and help by presenting multiple citations to remove the allegation that I might be cherry picking, to try and distinguish whether or not mass means masses, or are they the same? Are they interchangeable? So the first citation I'm going to read from is word hippo. I don't know how credible this is. It was just the first one I found when I started looking. What is the plural of mass? And it says the noun mass can be countable or uncountable. So in this instance, there's 14 of them, right? So we've got 14 mass, or have we got 14 masses? It says, in more general, commonly used context, the plural form will also be mass. So that's going with the idea that all 14 molecules can be counted as one mass. But it continues and it says, however, in more specific contexts, and there's no doubt that physics would be a more specific context, because it's important when you say things like gravity is not a force. I'm going to say that this is more specific. The plural form can also be masses, for example, in reference to various types of masses or a collection of masses. Well, the atmosphere is a collection of masses. There's nitrogen, there's hydrogen, there's helium, there's oxygen, a few other bits and pieces. The atmosphere that we breathe is a collection of masses. The problem is, if it is a collection of masses, that means gravity acts on them all individually, and there's no cumulative effect. Therefore, there is no weight. Therefore, there is no atmospheric pressure. So it's the distinction between mass and whether or not mass equals masses. I'm going to say it doesn't. I'm going to say that the 14 molecules are individual, they are not contained, and the only way that they could be treated as a cumulative is if they are in fact contained. Now we say that there must be a container. So what really seems to be happening is that the atmospheric pressure point is being claimed by ballers, but it has to be contained for them to get cumulative effect. But that would be our argument. It seems that they've stolen our argument because they need a cumulative effect to give them weight. But we say it has to be contained. So I'm going to say that you can't have it both ways. If there's no container and it's an open model, then you can't have the collective gas being treated as mass. You've got to have them as individuals. Otherwise, if it's contained and then you have the cumulative effect, then we must be contained. We can't be an open model. And that's really important. So I'm going to emphasize this several times so that the message gets through. But let's just see, now I've got the basic definition at the starting point. Let's see what other citations say to help me track, because I'm stupid, you see. I don't know whether mass is equal to masses or not. And I have to appeal to other citation because I can't use my common sense. I'm dumb. So I've had to go elsewhere to see what other people say about it. Memindex, or Memidex, whatever this is. I'm not familiar with this website, but it just gives multiple citations from different places all at once, and it seems to be convenient. It says mass, as in religious ceremony. The plural would be masses. It continues, and it says some more definitions from different citations: Wikipedia, Random House, American. Mass, inertial mass, gravitational mass, refers to the quantity of matter in an object. It doesn't say in objects. It says in an object. So in this context, we have an object in the middle, or we have a lot of objects. But the definition doesn't support it being a lot of objects. It says in an object. More specifically, inertial mass is quantitative measure of an object's resistance to acceleration. It doesn't say a collection of objects, does it? It says an object. So we're talking about one particle. We're not talking about a collection of particles floating around randomly in all directions. We're talking about one particle. This is not supporting the assertion that you can have mass as the whole atmosphere. If it is mass, it's talking about the singular, the individual molecule. That's terrible, even if you've got gravity, because it doesn't give you the cumulative effect that you need for your definition of weight within your model. Let's try another one. Random House Dictionary. This one says a body of coherent matter. A body. Not a group of things. It says a body. Again, it's singular. American Heritage. A unified body of matter. So unified body. Is this unified? Because you can say it's in a container and that makes it a body, but it's not unified, is it? It's disunited. It's not connected. So this is not consistent with the definition according to American Heritage. A unified body is not what we're seeing there. We're seeing a body, but it's not unified, is it? So let's try another one. We have the Macmillan British Dictionary says mass, and then it says in plural masses, which again is my position. This is supporting my assertion that mass is the singular molecule. It's not the collective, it's the singular. Masses, plural, a lot of. Well, we know that there's a lot of particles there, isn't it? There's got to be plurality there. There can't be singularity, can there? Even if it's inside a box, which would be our position. So, again, let's go back to the next one. Columbia doesn't say anything there. It's to do with religion. Oxford, oddly, doesn't say anything there. Cambridge Dictionary, it says a larger amount of something that has no particular shape or arrangement. It doesn't say some things, plural. It says something. So that something would be one of these. It wouldn't be all of these, because that would be some things, plural. Okay? So I've gone through there. There's 4 there, 5, 6, 7 there, 8, and then there's a base. That's 9. 9 things there that indicate that mass is singular. Masses would be plural. This is devastating if you believe that atmospheric pressure is the explanation on their model, because even if you've got gravity, and you haven't really got gravity, have you? It's not bendy space-time, but even if you've got gravity, that ticks that bit there. But you need the mass bit, and you haven't got the mass, because it doesn't say masses, it says mass. So if you haven't got mass, and you haven't really got gravity either, then you've definitely not got atmospheric pressure, because you need atmospheric pressure satisfying the definition. Satisfying atmospheric pressure is weight over unit area. Well, you haven't got weight, so therefore you haven't got atmospheric pressure. And that's before you even get to unit area. If you look up what area is, it doesn't even apply to this, because area is defined. There is no definition to an infinite vacuum of space, is there? And that's what they tell us that we're living in, an infinite vacuum of space. So atmospheric pressure is equal to weight over unit area. Unit area isn't a unit area when it's infinite, and weight doesn't have any mass to it, even if we give you gravity. Atmospheric pressure seems to be nothing more than a calculative correction to their model for them realizing that they don't have gas pressure. So what's really going on with the atmosphere? This is our atmosphere. And it's full of molecules. And these are individual molecules, not contained. Notice there's no box around it. And they want us to believe that this is mass. Well, we've just been through 9 examples defining them to be singular. So really the mass is the molecule. It isn't the collective. They haven't got atmospheric pressure, even if we distort the meanings of words. So pretty much in conclusion, atmospheric pressure does not exist even if they have gravity. We know that gravity is not a force, it's Einsteinian bendy space-time. Air is not mass. Air is a mixture of masses. The only mass that gravity acts on in their nonsense model is the individual molecules in isolation. There's no cumulative effect. There's no bonding between these particles. They're acting on their own. They're acting in isolation, independent. They're free to move in all directions. Because it's not cumulative, they don't have mass. Or technically they do have mass, but it's that small it might as well be zero. It isn't really zero, but you can think of it as zero because it's not the whole weight of the atmosphere pushing down on you the way they say. We do have pressure, but we don't have the mass that's making it. So how is it that they can explain gas pressure next to a vacuum if they've not even got atmospheric pressure? The lack of molecular bonding means that the mass is simply the molecule, and there is no real weight, only pressure. So we're going to come back now. I'm getting towards the end. It's quite straightforward. I don't know if Rumpus is here yet, but they have to demonstrate that they've got mass. By their own definition, weight and mass and acceleration due to gravity. Let's just give them gravity. They do not have mass. They've got molecules. That isn't a collective. It's singular. It's game over. Words of meaning. It doesn't say hot and mean cold. It doesn't say 10 and mean 2. It doesn't say mass and mean masses. If you think that atmospheric pressure is some kind of explanation that makes sense logically and reasonably, I'd agree. But you have to satisfy the equation. You have to satisfy that you have got mass, and you have to satisfy that you've got gravity. We'll give you gravity for this conversation. You haven't got mass, but you also don't have the unit per area either, because you need that area, and you haven't got area. An infinite area is not an area, is it? It's an infinite area. And if you divide or multiply anything by infinite, it's infinite. It's completely contradictory. So gas pressure can't exist next to a vacuum without some kind of container. You need it to be sealed to prevent entropy from bursting it all into space on their model, because without a sealed container, it's going to immediately vaporize and equilibralize and become that medium. We can't breathe on their model based on real world science. Their model is wrong. You can believe it if you want to, but you can't demonstrate atmospheric pressure because you can't even satisfy the definitions. So the question is, well, what really is happening? Because we do see layers to the atmosphere. It does look layered. Well, there is something that looks very similar to what we do see in the atmosphere, and Of course, it's just this. The little cherry tomato sits in the middle. That's a layer in our atmosphere. We know that nitrogen's got a heavier atomic mass than helium and hydrogen. We know that oxygen's more heavy than them two as well. What if helium and hydrogen are the top two, oxygen and nitrogen are the bottom two, and the other ones in between are the other layers, the other gases, and they're all ordered by their atomic value? It could even be an open container if the top part's not a vacuum, because it just needs to be a little bit less dense than the one that's above it. But if you've got a massive differential, like 10 to the minus 17 torr, then you're going to lose all of this column because all of it is massively out of differential. But when it's similar, that's when you can get the ordering. That's why Blue Marble Science kept his butane in his container that he doesn't call a container, because the butane is very close to equilibrium with the air that's around the container. But if you did it in a vacuum, the butane would be sucked out immediately. I know vacuums don't suck, but the differential is the point. It would be immediate and it would be violent. It would immediately burst into that vacuum, and that's what we can demonstrate. I've demonstrated it in this hangout. So Blue Marble Science did use a container. He didn't do it in a vacuum. He should do it in a vacuum because it wouldn't work. His claim wouldn't work. But overall, the point for the conclusion to this presentation is the atmospheric pressure claim fails because they can't satisfy their own definition. They don't have weight because they don't have mass. They don't have gravity because it's not a force. And they don't have any unit area because it's infinity. So if you multiply or divide by infinity, you get infinity. You need mass, not masses. And you need gravity being a force. So in Hillbilly Blue Ball's thing, his final sentence, which I think I can probably get. In fact, actually, his final sentence was, all you need is this being a little ball. No, it isn't what you need for atmospheric pressure. You need mass, you need gravity, and you need unit area. Hillbilly Blue Balls is wrong. You don't just need gravity and a ball. You need mass, you need gravity, you need a defined area. You can't have infinity, you can't have multiple masses, and even if we give you gravity, you still haven't got atmospheric pressure. Now, they'll claim that they can debunk me with counterclaim videos debunking me and laughing and ridiculing, that's fine. But unless you can satisfy your own definitions in your own science, then you ain't debunking shit. You need to satisfy the definitions. Otherwise, there's no point in having definitions. We need these equations. We need these definitions. The meanings of words are important. You can bitch, moan, and argue about the meanings of words because that's part of the job. But at the end of the day, if you're going to preach science, you've got to do science. And you've got to do your own science. And your model states that there are 3 things for atmospheric pressure, not just gravity on a ball. You need to have mass. You need to, not masses, mass. You need to have gravity. And you need a defined unit area, which is consistent with our model, because we've got all them, and it does layer the way we see it. It appears that atmospheric pressure is what they've hijacked in the real world is the density tower. We're living in a density tower. We're living in some kind of container. It's obvious because we can see it, but they've just bastardized the meanings of words because they need their model to kind of account for the stuff. But when you scratch below the surface, you realize the atmospheric pressure definition fails on 3 counts on the model. Now, I don't know if Rumpus is here, Ranty, but I'm done. I don't know if you want to bring Gently in or whatever, but you're going to have to explain how mass comes into this and how unit area comes into this, because I'll just give you gravity, but Ranty, I'm done.
Okay, excellent. Thank you very much for the presentation. There was, 16 slides there and a video as well. So, very well done. A lot of work went into that, so thank you very much. As you know, I'm not going to render an opinion on your presentation. I'll leave that to the audience. But you specifically asked for somebody to come in, so the Rumpus unfortunately hasn't got back to me, so it doesn't appear that he's going to be the one tonight. But I do have 2 people waiting if you're willing to take on 2. I mean, I think it's an unfair advantage, you against just 2. Maybe if it was 5 of them, it would be a fair thing. But are you willing to go up against 2?
Provided one of them does not fight the flat earth, yeah.
Right, it's not Fight the Flat Earth. It's well, let's just see if I can remember how to do this. So here we go. So add some people into the call. Right. Here we go. So I'm looking for, just 1 second. Let's get these names. Gently. Let's see who's on here. Gently doing it. Where is he? It's odd how I can't find him on that. Let's try somebody else. There we go. So we've got one. I'll bring him in. So this is Adam L. I believe you've spoke with him before, Tony.
I don't think so. Maybe, I don't know.
Okay. See if I can get somebody else in. Well, that's not coming. Gently isn't appearing, so I will have to find this the old-fashioned way. Maybe you can give me a call, actually. Gently, if you're there, give me a call, because for some reason I can't find you on my Skype right now. So, Adam, are you there?
Hello.
Hello.
Yes, I am.
Adam, meet Tony.
Hello, Tony. Last time we met, I was on JG Gonzalez, Jose JG Gonzalez show, trying to ask you a question, but you first made a strawman because meters per second square are not reading this way. And, well, first you started, strawman, and then you just made the runner. So, before... we have a call?
Yeah, 1 second, hold on. Let's see if I can answer the call. Oh. Let's get him on here. I'm going to have to add him on this way. Just bear with me, guys. Right, 1 sec. Right, you guys carry on. I'll continue to try and add gently this way.
Okay, no worries. So, last time we met...
Sorry, it's...
No worries.
I'm trying to add him to the call, bear with me.
Ronzi, just get him to send you a message first so he appears in your list, and then you add him from your list.
Alright, okay, so hopefully he's going to get that.
Okay. So,
right, guys, carry on.
Tony, what was your question? You are saying that the equation is saying about mass, not masses. And you are stating that it's calculated, the atmospheric pressure is calculated, even the gas pressure, which are two different things, is calculated over the field, yeah, like meters square, centimeters square, and this and that, inches square. So, they seem to be both the same thing, yes? But you are saying that there is no way acting in the atmosphere because the air weighs nothing. Well, let me surprise you that even if in our solar system we have at least 2 planets, if not more, that are made entirely out of gas. That's one thing, but you don't believe in space. So, apart from that, let me ask you this one simple question. Did you ever dive?
No.
Okay. Have you had your head somewhere below 1.5, 2 meters of water?
Yeah.
Yeah? Okay. Did you feel the pressure on your ears when you did that?
Yeah.
Okay. So, did you feel the same pressure acting on your eardrums when you were up on the surface?
Yeah.
Oh, you did the same pressure. You did feel the same pressure.
Not the same pressure, similar pressure.
Oh, similar. So when you dived down to, let's say, what was the deepest you went down to? Let's say 3 meters, 3.5, maybe.
Whatever, I don't know. 15, 16 feet.
But it was well, you could feel the difference within between the pressure on the surface and under the water. Yeah. And as you were going down, it was getting more and more. Well, you could feel it more and more. Is it?
Yeah.
Yeah. Okay. So that is your pressure gradient in the water. As water is the same thing as air, which is fluid. Water is liquid. Air is as well fluid. So as they both undercome the same laws, either on flat Earth, which you believe in, or on globe Earth, which I know is the fact, do you think there will be something similar in the air?
I want you to satisfy the definition for atmospheric pressure. It's
No, wait.
Doesn't matter what I think.
Mm-hmm. The pressure exerted by the weight of the atmosphere, which at sea level has a mean value of roughly 14.7 pounds per square inch. So you have the field that the pressure works on, and you have the weight, the word weight of the atmosphere. As you go up, the weight of the atmosphere becomes lower because there is less atmosphere acting upon you. Guess what tells this atmosphere to act in this vector, in this direction in your language, towards the center of the mass of the Earth? What makes it? What pulls it to the Earth? Because
I'm not sure what you mean when you say weight. Can we have a definition of weight, please?
Yeah, weight is mass by mass times gravitational acceleration.
Great. So what do you now mean by mass?
Mass is everything. You have the mass, I have the mass, the microphones we talk to have mass, and they are all being pulled down to the center of the Earth, of the gravitational.
Can I just introduce Gently's channel? I've been able to get him in. Hello, Gently.
Yeah, bye. How you going, my friend?
All good. Good to have you in. So, essentially, this is going to be like a 2-on-1 handicap for Tony to back you guys down with. So we've got Gently's channel and we've got Adam L, who are batting for the globe side, and we've got Tony, who's going to defend his position for the flat Earth side. So, you guys can carry on.
Cool. So let me just deal with the guy speaking, and then we'll come to Gently in a sec. You've just used the word mass. On screen, I've got, not you, Gently, the other guy. On screen, I've got 14 molecules that are contained in a box that appear to be bouncing off all the internal walls of the box. Yes. There's 14 molecules. Are the 14 molecules mass, or is it the singular mass? The singular molecule that's the mass?
All the 14... Well, it depends on the frame of reference you are going to use. If you're calculating the gravity for one molecule only, you will only need mass of one molecule. If you are calculating the mass of all molecules in this box, you'll have to calculate by the mass of all the molecules in the box. So if you are calculating the mass of something that is over 1 square inch on the ground, that takes about 1 inch square on the ground, but it will go up 100, about 100 miles up.
Okay, like so I went through about 9 citations from a variety of sources, and I'll just pick one at random. I'll just pick number 3. What's number 3? American Heritage, it says a unified body of matter with no specific shape. Now, in my...
Exactly. That's the frame of reference you take. Unified body of mass.
Yeah, well, it said...
The word unified actually means or suggests more than one thing, does it not?
Exactly.
No, unified means joined.
Why are you clinging to vocabulary?
Okay, well, we'll change it then. We'll change it, and we'll go with pick a number between 1 and 9.
Whatever, 7.
7. So 7 would be this one. Oh, that one's blank. So let's. Oh, hang on, no, I did give. Let's go back to it. So 1, 2, 3, 4, 5, 6. Sorry, it's 1 and 7. Pick a number between 1 and 7. Oh, so 7 would be the last one. Then Cambridge Dictionary, it says something that has no particular shape or arrangement. It doesn't say some things or a collection of some things. It says a something. So
you passed 2 words, 3 words. A large amount of something that has no particular shape or arrangement, which means it might be 1 molecule, it might be billion molecules, it might be your whole body.
So if there's a large amount of one molecule, that wouldn't constitute mass, then would it not?
It would still.
Sorry, let me rephrase that. I spat that out wrong. It says a large amount of something that has no particular shape. So are you saying a small amount of something would not be a mass?
It would be still a mass, because if it's large or small or just one molecule, it still has a mass. It depends on your frame of reference.
So
Stop playing with words, hiding that you know the Earth is a globe.
Why is it not plural?
Well, that's a good question for Cambridge Dictionary team, to be honest with you. Because
let's try this one. Let's try the one above it. The Macmillan British Dictionary says mass is...
Oh, wait. Go back. Mass. Entry 2. Masses. The mass of something. Mass of something. Yeah? That's a singular.
Which one? Where are you looking?
At the very same one you showed to me. Just cherry picking from the sentence.
Not cherry picking. I've got 9 citations.
Oh my goodness. Sorry, my bad. My bad accusations.
Right.
Masses.
Yeah.
Look at the second word.
Masses?
Yes.
Masses. Yeah. So
a large amount of something. So you cannot apply word mass in the equation to one molecule only. You apply word mass in the equation to the frame of reference you are using, which might be one molecule, one freaking atom, or even one electron.
Correct. That is the definition of mass.
There you go.
Yeah, but what you want to do is use the word masses instead, which would be the plural, and it doesn't say that.
Matter. Because in the Cambridge Dictionary you have it stated. Masses, a large amount of something. So that kills your point. Kills your point of mass being a...
To be fair, masses is plural in English. The way it's written. I mean, English is a very complicated language. It's probably the most complicated language and it has so many different variants on words.
You don't.
Hang on, stay neutral.
I am staying neutral, but I just wanted to say that I wanted to bring in Gently's channel at some point too, because he has been waiting. He's actually been waiting longer than you, Adam.
Sorry. One more thing to say. Yeah. You are saying that English is a hard language to learn. Try Polish.
Well, I think I can distinguish between singular and plural. It says, for another citation from Wikipedia, it says the quantity of matter in an object. It doesn't say in objects. It says in an object. Random House Dictionary says a body of coherent matter. It doesn't say bodies. It doesn't say a collection of bodies. It says a body.
Excuse me. Could you come back?
So the atmosphere.
Go back. Your
Yes.
citations are killing you, bro. So let's go. Random House Dictionary. Mass, Misa, blah, blah, blah. The masses, Massachusetts. Oh. A body of coherent matter.
Where are you looking? Which one are you going to?
Random House Dictionary.
Yeah, Random House. Yeah, a body of coherent matter.
Yeah.
Could one thing be coherent?
Hang on.
Literally a singular.
Is it a one? Is it a matter? A coherent?
Yeah. Otherwise, it would be matters.
Don't be silly. It's coherent. That means you've got more than one.
No, it doesn't. Coherent doesn't mean plural. Coherent means straightforward matter.
Coherent means sticking two things together. Like, quite literally. You can't stick one thing to nothing.
That's
to cohere something, you have to have at least two things.
That's cohesive. Let's have a look at coherent.
Ooh, Tony's debunking himself again.
Of an argument, theory, or policy logical and consistent, forming a unified whole. Not
which takes two into game.
No, uni means one. Doesn't mean two.
Why are you ripping parts of words when you cannot rip a word or just citation out of sentence? You are ripping part of a word out of a word.
Because
why are you doing this?
Because
this is just silly, bro. Forming a unified whole, which means coherent means that few things form a unified whole.
Yeah, unified, singular.
Unified. It's not. Don't rip the words.
No, but listen,
because this is not the point.
Listen. Your science says
you are playing with words again.
Stop.
You are playing with words again.
I'm not.
You can't unify a singular. You can't do it.
A singular is unified.
You are playing with words again, Tony.
Singular. Unifying a singular is ridiculous.
Yeah, it's not called a unicycle because it's got two wheels, is it? It's called a unicycle because it's got one wheel.
No, unify means to make two things one.
No, it doesn't. That's cohesive.
Okay, Google unify then for me, please.
Make or become uniform or whole. Make or become united. Well, it's already united. Uniform or whole. It doesn't say. It doesn't.
Make or become. It doesn't mean. It doesn't mean that it is
says,
already united. Make or become.
Unite. Bring together. Join together. Merge. Fuse. You're telling me you can do any one of those things with just one thing?
Okay, so let's go back to the position. Now, none of these items can be unified unless you've got a container. Now, I'll give you that you can unify them within a container, but on your model, there is no container. So how do you unify them?
Excuse me, but the thing is,
listen,
do you remember?
I need to interrupt, guys, just 1 second. It's to settle this discussion between what you would say about unified is. So in answer to your question, which was, is unified singular or plural? The answer, essentially, is... so in answer to your question, the United States can be singular or can be plural, depending on what you want to say about them. However, normally, if you're talking about the country, use the singular verb. So this is just what I've typed into Google. It's the first response that's came up in Google. So essentially, it's either or. You know, there's no easy way to say it. You're both right.
Well, I would say that they can only unify it if they put it in a box. If they don't, it's not unified.
No, because there is a gravity acting on it.
Yeah, I was going to say that. You can unify if they're all travelling in the same direction, then they're in unison.
Yeah, but that's not the position in the atmosphere, is it?
Well, no, it's in hydrostatic equilibrium.
Disequilibrium.
No, hydrostatic equilibrium.
Are you arguing about words again, Tony?
Yeah,
Are we here to discuss atmospheric pressure, or are we here to discuss your understanding of words?
well, we're not understanding my understanding of words, because when it says...
Because no one does.
No, I know that, and that's why I'm here. When we have the definition of atmospheric pressure...
Because
and
it's fucking crap.
So when we have the definition of atmospheric pressure, and it uses the word weight, and in physics the word weight is mass times little g, we'll give you little g, but we want to...
Don't be scared of the word you know so well, gravity. And you know it exists, and you know it acts on your fat bum, and you know, thanks to it, everything we look at, and thanks to it, we can look at it.
Are you done?
Yes.
All we're trying to satisfy is the meaning of the word mass in the context of atmospheric pressure. So words have got meaning. Now, my position is that the word mass does not mean what you guys think it means, because you guys need it to be the whole atmosphere. But when I've gone through the citations, it's quite clear that the plural of mass is masses. And in the context of 14 molecules in this example, there are 14 masses. But if you need the atmospheric pressure to be satisfied, you need all 14 of them to be a collective. So you need them to be one unified mass, but that's not what we have unless it's in a container. Then you can call it unified.
Can you?
Container. But your model is an open system and it doesn't have a container. So how do we get 14 molecules to be one molecule without there being a container? Because that's your model.
There is no one said they are container. No one said they are container.
Yeah, that means that you can't have mass then.
No, listen. No one said that they have to be contained to be thought of as a mass.
Yeah, I did.
Well, but it's you. Sorry. But you
need to demonstrate how you can get 14 molecules to be unified without a container.
Well,
or them moving in unison. It's as simple as that.
Yeah,
it's a bit like if you get an airline.
Gently, could you take over for a time being? No offense, Adam, but you've had a good 20 minutes here. Could you let gently just have another a 10-minute go with Anthony, and then a bit of back and forth, and then maybe you come back in a few minutes. Okay. So gently, go ahead.
No problem. Yeah, I know I'm ruining this.
So gently, gently.
Okay, so if you get an airline. Okay, and you blow through an airline, you'll see that you're pressing on a point with lots of different molecules of air.
Yeah, but they're in a box there, though, aren't they? So you could argue that they're unified. But on your model, it's an open system, and I've got 13 molecules in an atmosphere right now showing the audience.
This was the point of the airline. You see, if the air comes out of an airline as a stream, they are moving in unison.
I'll give you
Moving in unison gives them the force of the impact, whatever they blow out the way.
Yeah, but in the atmosphere, they're not moving in unison, and they're not in a pipe.
In the atmosphere, they're in hydrostatic equilibrium. They don't need to be moving in unison. They're in equilibrium.
But that means they can't be in union. They can't be unified if they're moving in all random directions.
They're not moving all random all directions. Some are, some aren't. But the bulk of them aren't because they're in equilibrium.
They push off the surface of the Earth in all directions. All directions are space. They're all in all directions. They are not moving in unison.
No. You're misunderstanding what hydrostatic equilibrium is. You see, gravity is acting upon them, so they are being vectored downward. The energy, the kinetic energy that they have...
They're not, though. I'll give you the gravity, but they are not being vectored downwards. They are being vectored in all directions at similar magnitudes.
That would mean then at the top of Everest it would be the same pressure as sea level. Why is it not? Why is there a gradient if they're moving in all directions with equal force?
Right, that's a straw man and it's a red herring. That's not the topic in discussion. The topic is how do you get mass to satisfy the definition for atmospheric pressure. It's not about gradient, it's about satisfying mass.
It is about gradient.
It is about gradient. You just obfuscated the point that I just made and changed the subject.
No, you produced a red herring
you just told me that gas molecules move in all directions equally. That means that at the top of Everest should be exactly the same pressure as sea level, but it is not.
No, it's not. This is a red herring argument, and I'm not going there. Your definition...
Because you've got no answer for it, that's the problem.
No, I do. The answer's the same on both models, but I'm not getting into it. We're trying to satisfy the definition of atmospheric pressure by satisfying the mass part for weight. If you can't satisfy mass for weight, then you don't satisfy the definition for atmospheric pressure, and your model does not do what your model claims it does. So where do we get mass from?
Okay, Newton's first law. All mass is inertial mass. And inside a gravitational field, all mass is gravitational mass. All mass is accelerating downwards at 9.81 meters per second.
No, that's not Newton's first law.
It certainly is Newton's first law.
No, it isn't. Newton's first law of motion is an object in motion will remain in motion unless acted upon by a force, or an object at rest will remain at rest unless acted upon by a force.
Which is quite literally the law of inertia.
That's not the way you worded it. That is not his law. You need to use the words.
The law of... No. That is the law of inertia.
Strawman again.
Right. No, not strawman. Words have got meaning, and
it is building a strawman, mate. Sorry to interrupt, but you did it the last time.
No. It's not. It's not.
You did it the last time, Randy Warrior. You did it the last time we met on JG Gonzalez show. Sorry, Jose. You did it the last time. I wrote 9.8 m/s, and there was this I don't know how to call it, arrow pointing up too, and you made an argument that this is not written like that. There should be a small 2 above it, and you left the chart because you had nothing to say apart from your word salad and clinging onto words and vocabulary. We are talking here about atmospheric pressure, which is caused by gravity pulling the atmosphere towards the center of the Earth. And as you said, gravity does exist. Pressure gradient does exist, which is the straight proof of gravity. Because if we had no gravity, as the second law of thermodynamics states, we would have equal pressure all over the container. But we don't. We have a pressure gradient for which gravity is responsible. And this gravity is giving us the atmospheric pressure, and literally because of this gravity we do, and everything we look at exists.
Are you done?
Yes.
Right. My friend here that's not you talking, and you were asked not to talk because it was supposed to be Gently and I, has incorrectly cited Newton's first law of motion. Newton's first law of motion is an object at rest. Can you stop interrupting, please? You were asked to go on mute. An object at rest remains at rest unless acted upon by a force. An object in motion remains in motion unless acted upon by a force. You did not read that, or you did not cite that when you said Newton's law, first law. What did you say about Newton's first law?
Newton's first law is the law of inertia. Now, if you would like to Google what is the law of inertia, I think you will find it is Newton's first law.
Newton's first law is not Newton's first law of inertia. It's called Newton's first law of motion, and as I've correctly cited on demand, it is an object in motion will remain in motion, and the same way an object at rest will remain in rest unless acted upon by a force. You have not got your laws of motion correct. Sorry.
Check, please.
Pardon?
Can you Google it to check? Can you put in what is the law of inertia?
I know what the law of inertia is, but you cited Newton's first law of motion, and that's not what you cited for inertia.
Why did you not use the exact words so our friend here could, just follow the text?
Because our friend here is conflating two terms, and I'm showing it to the audience.
No. I was asking the other guy.
What was that, sorry? Come on.
No, because Anthony here again builds a strawman again around. You did not say exactly what it says in the website I have found.
That's right.
Yeah.
And
That's why I'm asking him to specifically Google the word that I spoke instead of the words that he interpreted them to be. What I need
the word that you spoke
is the law of inertia.
That's not what you said.
You will find it is Newton's first law.
No, not what you said. You said Newton's first law. That relates to Newton's first law of motion, and you did not cite anything to do with an object remaining at rest. That's on screen. That's his definition, right?
You see that definition there? You see that definition there? That literally describes inertia. Literally.
Yeah, it's not
the word.
Inertia. Listen, inertia is not Newton's first law. You're describing inertia. That's not Newton's first law. You're confused.
No, I'm not. Newton's first law describes inertia.
No, it doesn't.
Based off Galilean relativity. No, I'm not confused. It is perfectly correct. That was Newton's nod to Galilean relativity.
Newton's first law
is not inertia.
No, Newton's first law is not about inertia. Sorry, you're wrong.
Then what is the text about then?
It's about an object in motion will remain in motion unless acted upon by a force, as I correctly cited without reading it. And then when I got it on screen, what do you know? I was right. It doesn't talk about inertia. What you're talking about is the law of inertia. That's not Newton's first law. You're incorrect.
When you define inertia, you will find those words. Exactly. Because those words define inertia. Newton's first law is the law of inertia.
Newton's first law is an object in motion will remain in motion unless acted upon by force. An object at rest will remain in rest unless acted upon by force.
Yes, and I'm condensing all that down into one singular word, inertia.
Right, all right, let's go with it. What point are you making?
I have no fucking idea where we started with that.
I can't remember what line we were on, but let's get back on the...
Atmospheric pressure is caused by gravity?
Well, yeah.
That's one of three parts. You need a volume and you need a mass. So how do you satisfy? Okay, so
have you never picked up a full gas bottle versus an empty gas bottle? Have you never done that? I do it every day.
Sure, but we're not talking about gas bottles, are we? In the atmosphere, we're talking about molecules. Would you agree that we're talking about molecules?
Yes, and an empty gas bottle has very little molecules, and a full gas bottle has lots of molecules, and lots of molecules are heavier.
Now, if we apply your analogy before with the hose pipe and the gas bottle, then you could unify the gas contents if it was inside the gas bottle. But we're not contained on your model, are we? So how do we unify the particles of atmosphere that we breathe when it's not contained? It's not unified. How do you make it unified?
It is contained by gravity.
It is contained. But the point being, it's in hydrostatic equilibrium.
Right, what's it contained with?
Everything is
gravity.
Okay, so Newton's first law of inertia, whichever way you want to call it, you can look for the definition of inertia if you like. Newton's first law tells you that anything in motion stays in motion. Anything that's stationary stays stationary. But that is in frame of reference. So literally everything in the universe is inertial. All mass is inertial mass, unless it's in the vicinity of a large planet. Then it becomes gravitational mass. Right?
Okay.
It's then vectored towards the planet.
Yeah, but
no matter how you look at it.
It's not. No. That's not true. It's not vectored towards the planet. They're going in all directions randomly. Well, that's not addressing the point. The point is, how do you unify the mass in this context?
Because they're moving in unison.
They're not. They're moving randomly in all directions, not in unison. It's the opposite.
Can you show me any citation that says the entire atmosphere is moving randomly in all directions?
Yeah, all the citations say that because that's what gas pressure is defined as. And you say, well,
I'm not asking for gas pressure. I'm not asking for gas pressure. I'm asking for hydrostatic equilibrium, not gas pressure.
What? But where does hydrostatic equilibrium fit into atmospheric pressure for the definition?
It literally defines it.
No.
Hydrostatic equilibrium is gas pressure under gravitation, or gas under gravitation.
Yeah, atmospheric pressure, you're not redefining what it says unless you've got a citation that allows you to redefine it as hydrostatic equilibrium. The definition on screen is the pressure exerted by the weight of the atmosphere. So can I have a citation for you redefining atmospheric pressure with regards to hydrostatic equilibrium, please?
Can you? Yes, you can. The PVNRT, the N, is in hydrostatic equilibrium. You will find, pressure equals density, gravity, depth, P, rho, gravity, depth. That is that's right. That's the formula for hydrostatic equilibrium, and you will find that.
Why is hydrostatic equilibrium? Why is hydrostatic equilibrium not part of the definition
of
atmospheric pressure?
Find a different definition.
Okay. Atmospheric pressure in physics, would that be enough for me to find something more suitable for you?
That could work.
Okay, so atmospheric pressure is the pressure exerted at the surface of a body. By a column of air in an atmosphere. So it's the pressure exerted at the surface of a body. It doesn't say anything about hydrostatic equilibrium. Where have you got this from?
Why don't you just Google hydrostatic equilibrium?
Because that's not the definition for atmospheric pressure.
Well, it is, because it's inside Pascal's law. It's inside the PVNRT, the ideal gas law. I mean,
so,
if it's in there, surely it's got to be correct, right? I mean, you were using PVNRT yourself, and you were using Pascal's law.
I know, but what I'm saying to you is the definition for atmospheric pressure in your current model is not what you're saying about hydrostatic equilibrium. That may be part of a definition somewhere, but in your model, atmospheric pressure is the weight of the atmosphere pushing down. So I want to see where you've got the hydrostatic from in your model, because it's on screen, it's defined as the weight of the atmosphere.
Yes, okay. Look at hydrostatic pressure. Hydrostatic pressure is the fact that because there's pressure, it's pushing upwards, and gravity is moving it downwards. That puts it in an equilibrium state.
I want you to link me the connection between atmospheric pressure and hydrostatic equilibrium, because it's on screen, it's the weight of the atmosphere. So where do I get the hydrostatic from for the definition?
Can you just Google hydrostatic equilibrium? Put it up on the screen.
I want you to satisfy the definition for
you won't do it, but I have to.
Yeah, you're making a claim.
I can't do it. I'm on my phone, dude. I mean, you've literally got it on the screen now. It'll take you 2 seconds to type it, bro.
It's the hydrostatic equilibrium.
Yes, please.
Right. Now, I'm looking for the connection that takes this to atmospheric pressure. So I wanted to link it. If you can't link it, then it fails.
Just click on that first link there. Just click on that.
Okay. Now what?
You're actually quite small on my screen. Hang on.
I can make it bigger. That might be better for you.
Oh yeah, that works. Okay, scroll down. Let's have a look. Let's have a read it. Not too fast. Not too fast. Right, what the fuck is that pop up? Right. External forces such as gravity are balanced by a pressure gradient force. For instance, the pressure gradient force prevents gravity from collapsing Earth's atmosphere into a thin, dense shell, whereas gravity prevents the pressure gradient force from diffusing the atmosphere into space. Does that satisfy your need?
For instance, the pressure gradient force prevents gravity from collapsing Earth's atmosphere into a thin, dense shell, whereas gravity prevents the pressure gradient force from diffusing the atmosphere into space.
Can I just ask, is the citation from anywhere decent, or is it from Wikipedia?
Well, I've just got it from Wikipedia. But the problem that I've got is, why is this different to the definition that we've got before from physics?
Because you cherry-picked the definition.
I didn't.
Because you don't know a lot about physics, you probably didn't hear the words hydrostatic equilibrium beforehand.
No, I have heard it.
You've just Googled about atmospheric pressure. Well, if you've heard about that, then you should have researched that and realised the fact that hydrostatic equilibrium is the reason why gas doesn't expunge into space and the reason why we have pressure equally.
So all I've done is
it's a part of fluid dynamics.
So in Hillbilly Blue Balls' video, he cited the University of Indiana, I think it was. I can't remember off the top of my head. Bear with me, I'll get it back on screen. I wouldn't want to misquote the guy because that's the worst thing in the world that anybody can do. It is the University of Indiana. And in the University of Indiana, they use the phrase atmospheric pressure equals weight of overlying air over unit area. Are you now telling me that Wikipedia has got a different citation and that's the one we should use?
No, I'm telling you that there are multiple ways of looking at it. It depends on what you are looking at specifically. You are looking there specifically at the gas. I am looking at the relationship between gravity and the gas.
I'm not. I'm looking specifically at what it says from the citation from Hillbilly Blue Balls from the University of Indiana. That doesn't say the same thing that Wikipedia says. I don't mind going with the Wikipedia one, but that means dismissing the University of Indiana, and I'd rather go with
No. It doesn't mean dismissing either. Both are correct. One is a term of the other. Like I say, atmospheric pressure, you are looking specifically at the gases and the relationship of the gases, what the gases are doing. Hydrostatic equilibrium, you're looking at the fluid dynamics of the atmosphere in relationship to the pressure and gravity.
So when we're looking at atmospheric pressure, we're not looking at the way it behaves, we're looking at the weight of the atmosphere. That's in the definition, and Hillbilly Blue Balls has correctly cited it. Now, if you're saying that it's not to do with the weight of the atmosphere and it's something else, I'm going to say no, because that's not in the definition, and I wouldn't want you to disagree with Hillbilly Blue Balls. So what is it? Are you going against... Are you going...
It's off right now, I guarantee it. I'm not going against what he said at all.
Yeah, you are.
To have hydrostatic equilibrium, you need gravity. And to have weight of gas, you need gravity. So either way around, we're looking at gravity pulling on gases.
I'm giving you gravity. I'm asking for the mass.
Well, what's the problem with the mass?
You haven't got any mass.
Well, even if I had 14 or 400 or 400 million, if they're all vectored in the same direction with the same force, I'm going to have pressure. That's it.
Excuse me, if I may interrupt. But you agreed before, Tony, that does have a mass because it does have molecules or groups of molecules or mass or masses of molecules being pulled by the gravitational pull of the Earth.
I didn't agree.
So you did agree.
I didn't. I contrasted between all of the weight of all of the molecules with the weight of one molecule because I contrasted the singular from the plural. You are incorrect, and you are either doing it intentionally
Wait. Calm down, because before you build another strong one.
Ranty, listen, I'm citing Hillbilly Blue Balls, and I want you to play the clip again and see, does Hillbilly Blue Balls call it the weight of the atmosphere, or does he say it's something else? Just play that clip again if you would. And then stop. When he said it, just stop it.
Okay, one sec. Well, I am going to play it for the audience, so I don't know how you're going to actually know what I'm actually saying, so what am I looking for?
Does Hillbilly Blue Balls cite the weight of the atmosphere, or does he say anything to do with hydrostatic equilibrium or anything else? Does he use any other word other than weight? Because if he doesn't, then we're going to go with Hillbilly Blue Balls because he's citing Indiana University. We can go with Wikipedia if you want to, but that means you've got to dismiss Indiana University. And if we do that, then I'm going to say dodgy, but we'll do it. But I want to see what Hillbilly Blue Balls says first.
In translation, if it agrees with flat Earth model, we will use it. If not, just get rid of it.
No. I'm happy to go with the Wikipedia one, but I want him to say that he's dismissing what Hillbilly Blue Ball says and what Indiana says.
If it does dismiss what Blue Marble says, then you will agree with it.
No.
If it doesn't, you will not. That's what you said.
No, that's not what I...
Okay,
that's me starting to play with words.
Well,
no, listen,
let me play the video. I'm playing it through Skype, so you can all watch it. So let me play it. It's 57 seconds, so, you can argue about it once it's been played.
Well, again, according to Indiana University, atmospheric pressure is now the pressure on the outside of the balloon. What does that depend on? Well, not an air compressor, that's for sure. In fact, what it depends on is nothing more than the acceleration of gravity. Atmospheric pressure is simply the weight of the air above any point. You know, we've gone through this and we've shown the derivation of the barometric equation.
Ranty, stop.
You've seen this before.
There we go. Right, so if you want to carry over and do your sharing of the screen, Tony.
So I'm going to say, I'm going to correct the previous statement by my friend here who said that I'm prepared to cherry pick the one that suits me best. I will go with whichever one you accept. If you want to dismiss Indiana University and Hillbilly Blue Balls, I'm happy to do that, and we'll go to Wikipedia instead. I don't think you should do, but if you want to do that, we'll do it that way. But I think that's going away from the definition, but it's entirely up to you guys, and I'll go with whatever you choose.
I have no idea why you need to dismiss one for the other when they both mean the same thing.
Exactly.
Why do you need to do that? What is your point in doing that? I'm not contradictory. The points are not contradictory.
You are. Because
please explain how they are contradictory.
Because Hillbilly Blue Balls in Indiana state the weight of the atmosphere, and you want to use the hydrostatic equilibrium point within Wikipedia.
Which uses the weight of the atmosphere as part of its calculation.
Right, but you're dismissing Indiana and Hillbilly. Now, I want to go with them two, but I'll go with Wikipedia if you want to. So I want you to pick. Which one do you want to...
No. There is no dismissing one. Literally just said that the pressure one that you've got contains what I've got. They are both the same thing.
They're not.
Why dismiss one?
Well, there's a good reason, and if we go to Wikipedia, then I'll show you for why. But you have to pick. You've either got atmospheric pressure defined the way Hillbilly Blue Balls and Indiana State University say, or we can go with what you claim is the same, which isn't the same, and I'll show you for why. But let's commit to one or the other, please. Make your decision.
I really don't care. Cherry pick which one you want and run with that. Because if you're not going to listen to they are the same thing, one is an explanation of the other, you just run with what you need to, bro.
I'm asking you to pick.
We don't pick. We don't pick. We go with both.
No, I can't go with both. They're in contradiction for a really...
Because... where? Excuse me, let me ask the question to our friend here. Where is the contradiction?
Well, that's what I want you to pick. Because if you pick the Wikipedia one, then I'll show you why it's a contradiction. If you don't pick the Wikipedia one, then we go with the weight of the atmosphere.
There is no
contradiction. Yeah, there is. I just want to read.
No contradiction.
Yeah, there is. I just want to emphasise the point for the audience so that you two have to commit to something. And if you realise that once you've committed that you've both made a mistake, I'm going to dwell on it and I know you won't back down. So just pick. Do you want to go with one?
The thing is, there is no difference.
Oh,
They both describe the same thing.
Exactly.
You are building a straw man again, Anthony.
I bet you
and I caught you out.
All right,
like this time.
All right,
just go with it. Just forget the gotcha moment. Just go with it. Let's see where you think I'm wrong. Let's have a look at what you think I'm wrong about.
No problem. So let's just be clear for the audience. I agree with Hillbilly Blue Balls and Indiana University that it's the weight of the atmosphere pushing down according to mass over gravity, mass plus or times volume, mass times little g. That's what we should be going with. These two don't want to go with it because they want to use hydrostatic...
Excuse me. Let me introduce you at this very moment because it was you who forced us or tried to force us to choose one of them. And we both went for both of the options. And you... No, wait.
Because I've told you.
Sorry.
No.
And you...
Contradiction.
And you said, you have to choose one. You have to choose one. And at the moment, after my friend here said, okay, let's go for any, you said, these dumbasses here chose one when I'm choosing both. When we both choose both options at the start.
Yeah.
You strawman, man.
No.
Yeah, for the record, I have not disagreed with Blue Marble Science in any way, shape or form. I actually respect the guy immensely.
No, I didn't say you didn't respect him. I said that you're disagreeing with him because me, Blue Marble, and Indiana State University give the same definition for atmospheric pressure. You guys want me to go into hydrostatic equilibrium, and I don't mind
No.
doing
That's your strawman that you build around whatever we said.
Stop
Playing
interrupting.
with the words.
No,
I will be interrupting you because I have been interrupted too many times. Trust me. And the Globers have been interrupted too many times on Flat Arts channels. So I will be interrupting you. So it was you. Stop. It was you. Stop, you dumbass. Sorry, not an Oakley way. So it was you.
Yeah, I would like to say, I mean, if you can't have a civil debate, then, there's no real point in this continuing. I don't want it to go down a route where you're just going to continually interrupt. Please respect each other and allow this conversation to progress. This is what this platform's for.
Sorry.
Okay, it's not to be the Globers side of Nathan Oakley. This is to be Ranty Flat Earth channel on the round table where you each get an equal say.
Okay, but he is allowed to interrupt anyone, and no one is allowed to interrupt him.
To be fair, in Tony's defence, he is 1 against 2. So, carry on.
The thing is, let me finish, Tony. Okay, let me finish. Just let me finish. I was sitting quietly for a while now. Okay, so you are building a strawman around us, apparently saying, as Globies, saying that, we will go for 1, because you said you were talking about for about 5 minutes. Choose one. Which one is the correct one? We both told you they're both correct. And at the moment you get your voice, and at the moment, well, for the sake of their sanity, we chose one option when we both support both options. You went, I agree with this, and we all three have the same saying, and you are stupid because you are only pointing to one. When we did it on your request. So, is that hypocrisy, or my English is really bad?
Are you done?
Yes.
Yeah. Should we move on to show me where I'm wrong then? That hydrostatic pressure is exactly the same as atmospheric pressure.
Okay, now what I want to happen now is the other guy that's been continuously talking over me but claiming victim status to go on mute while I do this so that I can get my point out, please.
That seems fair. It is your presentation, Tony. You go ahead. You need to start sharing your screen because at the moment we are actually looking at Adam L's presentation screen. So I don't really want to see that.
Okay, can you see my screen, Ranty?
1 second. Let me get you up. Yes, I can see it. I just need to make sure that everyone else can see it too. There we go. Right, go ahead.
All right. So I'm now going to show you where the contradiction lies, and I want you to agree with me or disagree with me once I've made my point, whether or not I'm correct by pointing out a contradiction. Okay, gently.
Yeah. Go for it.
Okay. Now you want me to go down the Wikipedia atmospheric pressure to get to an hydrostatic equilibrium point. And I'm inviting you to guide me into that so that we can get to where the hydrostatic equilibrium point is. Now, it looks like it comes from this paragraph here on screen. It says, in most circumstances, atmospheric pressure is closely approximated by the hydrostatic pressure caused by the weight of the air above the measurement point. Is that where you get it from?
That wasn't where I got it from. No, I got it from A-level physics. But if it says it there, that's fine. Let's go for that.
Okay, well, this is where we have a problem, because if I then go to what hydrostatic equilibrium says, it says, once I get rid of this, close that, it says in fluid mechanics, a fluid is said to be in hydrostatic equilibrium or hydrostatic balance when it's at rest. Is the atmosphere dynamic or is it at rest?
It depends on the frame of reference.
Explain.
Okay, so Just because it's moving left or right, or a large portion of it is moving left or right, it doesn't mean to say that it's not all moving downwards and left and right.
Yeah,
It doesn't mean to say that it doesn't have weight while it moves left or right. It doesn't mean to say that it's not pushing on something while it's moving left or right.
No, but what it does mean is if it's not at rest, then it's not got hydrostatic equilibrium, which was the point you were relying on it when you cited that we should go here.
No, that's just your claim. Just because you found the words at rest.
No, it wasn't. No, it wasn't my claim. This was your claim, and I said there was a contradiction, and now I'm highlighting it, and you're saying that I'm focusing on the word at rest. That's the contradiction.
Guys, whose fire alarm's making this? Whose fire alarm's making that beep? Because it's really pissing me off. Someone's got a fire alarm.
That could be me. I'm standing in the kitchen and the battery's going flat. I can't really do much about that. I'm sorry about that.
It's all right. It's fine. It's just I just wanted to know whose it was because I had one of these about a month ago, and yeah, I literally ripped it off the wall and stamped on it because it just wouldn't shut up.
Yeah, I'm not far from it, to be fair, but it's the one in the kitchen, so the missus won't let me.
Right, carry on.
Okay, if you continue to read, it says, this occurs when external forces such as gravity are balanced by a pressure gradient force.
Now, are they ever balanced by a pressure gradient force in the real world?
Yes, because if it wasn't, it would either collapse through the atmosphere into a thin layer, or the atmosphere would burst into space. Neither one happens. Therefore, it must be by definition, yes.
Let me give you 5 reasons why it's not at rest by in real world in the atmosphere. 1, the sun creates convection currents. The sun creates the hydrological cycle, the nitrogen cycle, the carbon cycle, all of the cycles that go on in the Earth caused by the sun. The sun makes it not at rest. It's not balanced by a pressure gradient force. It's continuously dynamic.
Excuse me, about the sun. I have a question. There is a summer in northern hemisphere and there is a summer in southern hemisphere. And when there is a summer in southern hemisphere, you can see the sun from the, regions of Antarctica 24/7. How can a globe explain this?
Nancy, I think this guy's trolling. This is called a red herring. It's not a point on topic. It's off topic. Who cares? We're trying to talk about whether or not the atmosphere is at rest. And I've demonstrated that the sun causes numerous cycles, and it's never at rest because the sun is always out somewhere. No matter on both models, the sun's out somewhere. The atmosphere is never at rest. So we can't be in hydrostatic equilibrium. And I told you there was a contradiction, and now I'm pointing it out, and I'm saying this is not consistent with real world.
If I'm going to, if I have to make a ruling here, I have to absolutely agree. The atmosphere is always in motion. It's just a fact. It's to deny that is just insanity.
I'm not suggesting that it isn't in motion. I'm suggesting that the motion is balanced.
Yeah, but it needs to be at rest. It needs to be at rest.
No, it doesn't. It absolutely doesn't. It's hydrostatic pressure.
Yeah, but look, it says when it is at rest or when the flow velocity for each parcel of fluid is constant over time. The only time it's ever going to be constant over time or at rest is when there's no sun.
Or when it's being pulled down at 9.81 meters per second squared constantly.
But we still have...
Yes.
We still have weather, and that in its by definition is an imbalance in pressure, humidity, a variety of other things that make weather what it is. It's never in rest.
That weather does not change the weight of mass.
No, but it does change the importance.
Remain constant in a gravitational field.
Yeah, but that's not the point it's proving.
The concentration of mass, there's a law for it.
Yeah, but that's not the point we're trying to establish. The point we're trying to establish is the justification for departing from what me, Hillbilly Blue Balls, and Indiana University said was the definition, which was the weight of the atmosphere above us, going towards Wikipedia and a reliance on the hydrostatic equilibrium, which can't apply because the atmosphere needs to be at rest, or when the flow velocity is constant over time, and it's never either of them.
Excuse
of course,
me.
it's constant over time. It's being accelerated downwards at 9.81 meters per second squared. All of it for all time.
It
Of
is.
course, it's in a constant flow.
No,
It
listen.
has to be by definition.
Yeah, but in real world, we have the sun that heats everything up and causes convection current.
Excuse me. Excuse me.
No,
Monty.
shut up.
But that doesn't change the weight of the mass.
No, but it does.
So-
It does negate the ability for you.
It changes its vector, maybe, but its weight remains the same. And how long can it change? its vector?
No. Stop. That's
There's only a very small period of time that a
Listen.
gas molecule can contain enough kinetic energy to travel in a direction.
Listen, your reason for coming here wasn't because of the weight of the atmosphere. It was because you wanted to rely on hydrostatic equilibrium. But when we look into the definition, and I told you there was a contradiction, when we go there, it relies on the atmosphere being either at rest or having a constant velocity over time. And it doesn't do it. It's got nothing to do with the weight of the atmosphere. It's to do with whether the atmosphere is moving. And we have weather. So it's never in hydrostatic equilibrium. And this is the contradiction I told you about. And that's why I gave you the opportunity not to come here.
Would you consider time to be forever and always, right? And would you consider a constant to be always 9.81 meters per second? Because I think my definition fits very well with that sentence there.
No, it doesn't. This sentence here
Gravity
is...
a constant.
Yeah, but, right, look, in fluid mechanics, a fluid is said to be in hydrostatic equilibrium or at hydrostatic balance when it, being the atmosphere, is at rest or when the flow velocity for each parcel of fluid is constant over time. We don't get that in an atmosphere, and that's why I didn't want to come here. But you wanted to come here because you were curious. Well,
You
now...
literally do get it. The weight of gas never changes. Gas will be the same gas.
It's
the
not...
weight of mass. There is a conservation of mass law. Okay? It's never going to change. When you have a mass, it will remain that mass.
Lanty.
All of the mass, all of it is accelerating downwards at 9.81 meters per second. That means that fluid is in constant motion over time.
Yeah, constant motion, not rest.
And I think you'll find that statement says, or when the flow velocity for each parcel of fluid is constant over time, which it is.
No,
Can you prove that it isn't? Can you prove that the gas doesn't have weight?
No, it's not about that. It's about whether it's moving, and you're creating a lie. This is dishonest. This is not what it's talking about weight. It's talking about whether it's moving or not.
Yeah, I do have to agree with Tony here. It is when it's moving, and you can actually even read it, or when the flow velocity for each parcel of fluid is constant over time. That means that's essentially staying stagnant, not moving at all. It has to be. Go on.
Sorry, mate. I didn't want to interrupt you there. I just couldn't.
It's just that I've listened to you guys arguing, and it's like it really is in black and white. It says it here.
Yeah. Look at it like this, Ranty. When you run, okay, you weigh the same, don't you? You know, you haven't lost weight. You're not a skinny dude just because you're running. You can be running as fast as you can. You're going to still weigh the same. You can run uphill. You can run downhill. You're still going to weigh the same. It doesn't matter if you're moving. Your weight will remain constant. That means your flow, your direction of travel is irrespective of your weight, and your weight is based on your gravitational force.
Yeah, but this isn't talking about weight, is it? It's talking about movement.
Yeah.
Yes, but gravity will draw the thing downwards towards the Earth, no matter what. No matter what, it's a constant.
But that would then mean that convection currents don't exist because all matter's coming down, and that's not the case. Convection currents do exist because we have all of the hydrogen cycle, the oxygen cycle, all of the cycles,
Excuse me.
And their weights remain the same. They're just travelling in different directions. It's the conservation of mass.
It's not about weight. Look, it's not about weight. It's when a fluid is at rest. That's
Excuse me, but is not pressure a weight over atmospheric pressure in which we are talking about here? Is it not measured in weight over a field?
Who cares? We're talking about whether the atmosphere...
It's not who cares, because that's the topic of atmospheric... Round table 26. Atmospheric pressure does not exist.
Yes.
Leaky warrior. Runny warrior. So that's the topic we are talking about. So atmospheric pressure is being caused by the gravity, which pulls the air molecules, which is nitrogen, oxygen, CO2, blah, 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 name it. Molecules being pulled to the center of the Earth. And that's the topic. And you're
not. What you're doing is you're moving away from the definition because you know that you're beaten and you won't admit it.
No, I don't know if I'm beaten because I don't give a penny about what the definitions state and about your word salad and your cherry picking from sentences of things that will support your point. The thing is, gravity is pulling atmosphere towards the center of the Earth. And you are feeling it if you go higher or you go underwater. You feel the pressure gradient, which causes the atmospheric pressure. Don't try to interrupt me. Sorry.
Listen, I gave you gravity. It's not about gravity. It's about the other parts. There's two parts to the equation that you haven't satisfied. You can't satisfy them, and you're accusing me and calling me...
What parts of equation do you want me to satisfy?
Mass and the unit area. That's the equation.
Unit area. Square inch. Measure it with a ruler. You have the unit area. Yeah? Mass.
We haven't got mass.
If you gave me the gravity, so imagine over that 1 square inch of a field on the surface of the Earth.
Yeah.
You have a column of 100 miles of air.
Is this
that is dense at density at pressure of 14.7 psi.
Okay, right, guys, listen.
At the bottom and goes all the way up with its with the pressure measurement going down almost to zero.
Ranty, I think I've said
well, here's what I'm going to do, guys. The Rumpus is ready to jump on in. So what I'm probably going to do now is, and I do appreciate you guys actually both appearing this evening, Gently and Adam, but I'm going to allow the Rumpus to take over. So Tony, if you want to jump off the call, I'll recall you back in a moment. I'll bring the Rumpus in, and yeah, I mean, both of you guys handled this incredibly well. Thank you for turning up, but I am going to bring the Rumpus in right now. So I'll see you soon.
Yeah, thanks for the opportunity. I'll speak to you all soon.
Tony.
He was just trolling, Ranty. I know Gently was having a go, but he was he was trying to make it about the weight, and it was about the movement.
Okay, so we've got the Rumpus in finally. I know that he says that he didn't actually receive the notification prior, so the Rumpus, are you there?
Oops.
Oops, yeah, you're there.
On the yep.
Excellent stuff. Listen, before you guys get into this, I would love to read the super chats that have gone through this evening because there's quite a few. So, just give you a couple of minutes just to actually set up. The first one we got was from let's see, wow, Godzilla 37. Thanks for your work, Ranty. From Dave Rakia Gafford was shout out to all the truth channels, Rakia Life. Again, Dave, shameless plug, Bible Literalist, Tuesdays at 6 p.m. Paula is ace. Have to agree. Go and subscribe today. Vlad on Flat Earth, we all experience flat and stationary Earth. We had a $5 super chat from Cleary who said somebody needs to change the battery in their smoke detector. Yeah, that was quite annoying actually. JQ says, with a massive $20 super chat, said, a pint for both you and Tony. So the next time I see you, Tony, I will buy you a pint. Glad to see you back, Ranty, and it's good to be back, actually. And lastly, from Rob Keane, a Canadian $10 chat, said, Rack your life. Shout out to Jesus the Christ. So, shout out to Jesus Christ. Glad to have you in here, the Rumpus and Tony. If you guys want to carry on, I'll put myself on mute.
Rumpus, how much have you heard? Have you not heard any of it?
Not heard any of it. No, not just the last 5 minutes. Because you didn't give me a date or tell me this is when this was going to happen at all. I've just come back to find you sent me a Skype message, or you were around at 8:30. I haven't been here for the last couple of hours, and then I've just come back to find 8:30 a message from you saying you're supposed to be in a debate. You didn't give me any warning at all. No notification whatsoever. Unbelievable.
It's Ranty, that, not me.
Well, incredible. I mean, we agreed to have some sort of debate, and then I find this evening apparently it's been arranged. No one told me.
Well, I rang Ranty today, or me and Ranty spoke on the phone, and after it was about 2:00, and I said, run it by Rumpus, make sure that he's okay with it. And then, as far as I know, he contacted you, never heard from you again. I mean,
the only contact I've had from Ranty is at 8:30 this evening, saying that you're going to do a presentation. That's the only contact I've had with him.
Do you want to address that, Ranty, or should we move on, or what?
Well, we did actually get into a chat. Was it yesterday that you said that you had somebody ready to do this? To be the sacrificial Glober to come on and debate you. And I believe I asked who, and then you said it was the Rumpus. And then this evening at 7:45, I said I'll start the show at 9 p.m. So that's
you never
also
mentioned a date yesterday. You just said we agreed to have a debate with Anthony. We never mentioned a date or a time or anything, whether it's going to be this year, next year, or in 10 years.
Hang on, let me have a look back up, because I'm sure I suggest...
You didn't tell me. You didn't tell me until 8:30 this evening is the first time I got told that something was happening.
Well, I personally messaged you today at 8:30, yeah. But in the group chat, I did actually message yesterday and at 7:45 today, but it's all good.
Not
it doesn't.
We're having a debate today, Ranty. You just said you mentioned something about being a bonehead. That's all.
It's okay.
It's all right. Mention of a date or a debate or anything.
Rumpus, we'll blame Ranty. We'll blame Ranty.
I'll tell you what. I'm happy if you want to blame me. That's fine. You guys carry on. You're here now. Let's have this.
So basically, let's just make it brief, Rumpus. Just quick yes/no's to get to the same conclusion, right? Do you agree that atmospheric pressure is the weight of the atmosphere pushing down in a column above your head?
Correct.
Okay, so it uses the word weight. Do you agree that weight is defined in physics as mass times little g?
Correct.
I'll give little g for the sake of this conversation. My issue is with the word mass. How do you get a collective mass when all the molecules are in singular form, zipping around in all directions, and mass, the plural of mass, is masses?
Well, it's irrelevant. Does it matter if you've got 10 apples in a bag standing on your head, or 10 apples not in a bag, or you want to weigh 10 apples? Does it matter if you put them in a bag and weigh them, or if there are 10 separate apples and you weigh them? Doesn't make any difference.
Are you saying that the atmosphere is contained?
No. Well, it's contained by gravity.
Gravity's not a container.
Yes, it is. Effectively acts like a container.
How does it do that?
By applying a force. Every little molecule that's in the atmosphere has effectively got a little spring attached to it, being pulled to the centre of the Earth. It doesn't quite. The rules of the force aren't quite the same. But you can think of every little molecule as being pulled to the centre of the Earth, like as though it's on a little spring. The spring, unlike springs though, which get stronger, the force gets stronger as you extend them. As they get further away from the Earth, they get slightly less. But because the atmosphere is fairly narrow, the difference in the force is not that much, but fundamentally all the molecules in the atmosphere have got little springs on them pulling them to the centre of the Earth.
Okay, so the molecules that are not going towards the centre of the Earth, have they still got little springs on them?
Yeah, it doesn't matter which direction they're going, and it's like when you throw up a cricket ball. You can throw a cricket ball up.
Okay.
There's still a force acting on it to pull it down.
Okay. So the molecules that are going away from Earth, then, if they're being acted upon by a force, which I'll agree to for this conversation, I'll just say it is. Would you agree that it's inversely proportionate to its mass?
Sorry, what's inversely proportional to the mass?
The force of gravity?
No, it's directly proportional to the product of the mass of the Earth and the mass of the thing that's being pulled. It's F is equal to G, big G, not little g, big G, times M1, the mass of the molecule, times M2, the mass of the Earth, divided by R squared, which is the distance between the molecule and the centre of the Earth.
Okay,
so it's proportional to the product of the masses and inversely proportional to the distance squared between them.
Can I have a citation for that then? The product of the masses.
Yeah, well, that's just the universal law of gravitation. The F is equal to G M1 M2 divided by R squared. It's the normal. It's the standard Newtonian law for attraction. What, you cannot not be aware of this.
I want to see the sum of the masses because that's not the way I understand it.
Hold on. Let me present. Shall I? Can we?
Yeah. A citation, no, not Forbes or Quora, something that we can rely on that's credible.
Well, okay. Right. Oh God. Right. Okay. Let's go. Well, I mean, you're just asking me to cite a basic.
It's the sum of the masses bit that I want citation for.
Well, it doesn't make any difference. You just add them together. Hold on. Let me just get. Why is my Windows not showing up as? Sorry, I'm just having a.
Because it doesn't use the word masses in the definition. So if you
5 apples added together is the same as 5 apples separately weighed.
No, it's not. Yeah, but you can only add them together if you contain them in a box. If you don't contain them in a box, then you can't add them all together, can you? Because you've only got one apple.
Hold on, let me. Where? So I'm just having a problem. This new thing seems to be showing my
I'll go and get it while you're sorting that out. I'm going to get.
Right, got it at last. Bloody hell, Jesus Christ! Right, so, hopefully I'm sharing the browser, and then.
Yeah.
Oh come on, thing! Bloody stop messing about.
Nice to see you keeping up to date with the Flat Earth International Conference, Rumpus.
Oh, someone just gave me a link. Someone gave me a link to that. I haven't looked at it yet.
Oh dear.
I can't believe you got Dr. Becky next.
Oh, my browser's doing this little trick of. Oh, right, you bastard! Come on. Right, so just.
It might help if you remove some of the tabs. Just saying.
Yeah. Yes, actually, you actually.
659 tabs. Is that what that means in brackets? There, Rumpus.
Could do.
That's a lot of tabs, man.
That is a failed number, isn't it? Anyway, let's the
sum of the masses for
hold on, let's just get this thing you seem to be having a problem with. Universal law of gravitation.
Yeah, I want to see where the sum of the masses. If that's there, then that's interesting.
But Anthony, an apple is made up of lots of separate atoms and molecules, each one being pulled individually. Yeah. So it makes no difference.
No, it does, because if you can't cite a sum of the particles, Rumpus, then you haven't got the point you're making.
I have. Right there, this is the formula, okay? Go away. Right, so this is the formula here. This is Newton's. That is the formula here. So that's the universal. So, but it does. So this is the mass of the Earth is M1, let's say, and M2 is the mass of any particular thing.
Sure. But some of the masses bit. That's the bit you said.
Hang on. Can I just say that JQ sends a pint over Rumpus. He said a pint for Rumpus too for bringing more people to Flat Earth every day. So if we ever meet up, Rumpus, I will buy you a pint.
I'll buy a pint.
I will.
Right. So what you don't understand.
I'll buy him 2 or 3 pints. Actually, he's been ace.
Right, I see. Right, so let's So here I'm now writing out the formula that you saw.
I want to see the sum of the masses.
Yeah, I'm about to show you. I'm about to demonstrate mathematically why that works.
I want citation, not calculation. I want you to see where.
It's a simple addition, Anthony. It's just a matter of simply adding things together. Addition doesn't require a citation.
No, it's not addition I want the citation.
It is. I'm going to show you it's addition. I'm about to demonstrate to you.
I want you to cite where it allows you to add the sum of the masses to get mass. Because
addition.
Right. No, I want citation, not addition. Citation.
Yeah, because no one is stupid enough to think that needs doing because it's just a matter of adding. So, for instance, this M1. So here we have. So we can say M1 here.
Citation, please, Rumpus, not calculation.
Well, that's all because no one's stupid enough to require such a thing.
Yeah, but it's specified.
So that's the mass of the Earth. Hold on, let me. So that's M1 there. And if we have,
No. Some of the masses we want sightings.
Well,
Not
does it make any difference? So the question is, let's go and get an.
It does, because
No, it
the
doesn't.
is,
Hold on. Let me
explain why. Let me explain why. If you've only got the molecules on an individual level, you haven't got enough mass there for it to act as a weight, because it requires mass singular. But if you've only got singular molecules, then you haven't got any mass. So where's the gravity?
You haven't got any mass. What are you talking about?
The molecules mass is very, 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 very. It's almost zero, Rumpus.
Yeah, but that's what makes up an apple. An apple is a collection of very small, very near massless atoms that all added together form the mass.
Yeah, but they're contained with the skin of the apple, though, aren't they?
Doesn't make any difference. Do you saying an apple without a skin?
The
Are you telling me? Hold on. Are you telling me if I take all the atoms apart in an apple and then I weigh it? Oh, bloody thing.
Yeah, I'm saying that the apple is united, isn't it? It's part of a unified object, a singularity.
It doesn't make any difference.
It does, because it's contained.
It doesn't. You're just making stuff up, Anthony. You're just making stuff up because you don't have a basic feel for physics or anything.
No. I'm contrasting. You're saying that the atmosphere acts as a unified whole, and I'm contrasting with that and saying it doesn't.
Here we go. Let's try and get this. Here we go.
Try getting rid of like 700 of those the tabs. It might help. Or just run Task Manager and see which resource is taking up the most resource and get rid of it.
Well, actually, it doesn't. And when I do that, it tells me that oddly, when it does misbehave. Oh, bloody Skype is the thing that's actually annoying it. It's a screen grabber. It's actually the screen grabber. This is what really annoys it. Hold on, I'm just going to try and get a bloody picture of an apple, because I know the only thing you can understand is. Here we go. The only thing you understand is pictures. Right, here we go. So there's one apple.
Hang on, why are you running screen grabber?
Well, it's Skype, because I'm sharing my screen. The screen is being grabbed by Skype to send to you.
Yeah, but you just said you're running screen grabber. That's like
no, I'm not really. No, when I say screen grabber, the screen grabber in Skype is doing it.
It might be the 700 tabs you've got open.
Yeah, that one. Well, anyway, so here we have 5 apples. Now, what you seem to be saying is it makes a difference. Let's suppose I took apart this apple here into all its constituent atoms. You're saying, in some strange, wacky, idiotic, sub-primary school understanding of the way the world works, that's going to weigh less than if I have the apple together. The fact that it's got a skin on it makes no difference. Let me go. Well, is this what you're saying? It's exactly what you're saying.
It's not, Rumpus.
Exactly. So let me go and get. Let me just go.
Rumpus, let me re-explain it, because you're missing the point that I'm making.
No, I've got exactly the point.
Rumpus, please, let's listen. Just listen. Mass is singular. Masses is plural. When it says mass for the definition of weight, it doesn't include all of the molecules. It only refers to one molecule because it's mass.
Yeah, but it's just adding, Anthony.
No.
5 apples added together are the same mass as one bag of 5 apples, if the bag doesn't weigh very much.
Yeah, but unless the atmosphere is contained, Rumpus, you can't use them.
We're not talking about anything to do with the atmosphere. We're talking about an object. Let me just try.
We're talking about the mass for the molecules for atmospheric pressure.
It doesn't make any difference. It's just like apples, Anthony.
No, it does.
Right. It's exactly the same. So what you're saying is, if I have 5 apples here and I put them there all together in a bag, let's put them in a bag here for you. So you're saying if I put those in a bag, let's make that. By the way, that's going to weigh different. Oh, bloody thing! Hold on.
We're still looking at Wikipedia.
Oh, God. Oh, sorry. Oh, no wonder. Oh, right. That's no wonder you're. Okay, sorry about that. Stupid bastard. That's a bit of a stupid bastard thing, wasn't it? Sorry. Okay.
Just say that when you put the apple back.
Sorry.
When you put the apples in a bag, Rumpus, that's like putting the molecules under a dome.
Right. Here we go. Sorry. There we go. So I didn't realise we were.
I've missed you guys. You guys are just ace.
Here we go. Right, so I've been busy drawing this picture while I was showing it the wrong screen. So here we go. Here is the law of gravitation. Here's the universal law of gravitation. There we go. There we are. And so this is my bag of apples here on a thingy.
Yeah. So the atmosphere is contained then, Rumpus.
Can you see the apples? Can you see all this? Can you see apples on a scale? Great.
I've got 2 objections. Can we deal with my objections before we go any further?
Let me just draw the diagram first, and then you can object to the drawing. So here we have 2 situations. I have, and then let's suppose I now dismantle all of these apples. Let's suppose I turn them all into their component molecules. So I rip them apart using, I cut them up with a very, very fine knife, and so that I'm now going to represent as one molecule of the apple. and then say, imagine that all these molecules are apple molecules, which are going to be different all over. Let's make them red. What you're saying is that if I break apart, let's get rid of the bloody line width. Make it red. Make it a bit bigger. Right. So imagine I'm going to just leave it like that. But imagine all these little red blobs are apple molecules. And what you seem to be saying is that if I break this apple into all its constituent atoms, it's somehow going to weigh a different amount. How can you be so stupid?
That's not what I'm saying.
Exactly what you're saying.
Right, I've got 2 objections, Rumpus, and I want you to listen, and I want you to respond to the 2 of them after I've said them, okay? I asked you for a citation that allowed you to add the sum of the masses together, and you haven't provided one. I still want one. And the second point is, unless you put them apples in a bag, you can't call them a mass because they need the bag to be in the mass because then they're unified. But if you haven't got a bag for them to go in, which is the atmosphere, that hasn't got any containment, then you can't call those 5 masses one mass because they're 5 masses. So deal with both points for me and show me how I'm wrong.
Right, because things add together, and 5 apples, if I were to split this apple here into its constituent apples, then if I were to separate them so they were not touching one another, I pulled all the atoms and molecules out of this apple and I put them in a pile so they didn't look like an apple anymore, but it had all of the atoms and molecules from it. So I had, remember 1 mole is 6 times 10 to the 23, so I'd have 10 to the 23. That is 1 mole, which is about a kilogram. So that would be 1 gram of hydrogen. Would be 1 with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 19, 20, 21, 22, 23, 24, 25, 26. So that's 1 gram of hydrogen. Is that many components? So you can imagine an apple is probably another couple of those. So there we have. So that's how many atoms there are in 1 apple. So you can imagine those little things representing an atom, or that number of them, you seem to think, well, let's establish, do you agree that if I took all the component atoms of an apple, I separated them all, took them away, every single atom I separated, and I weighed it, are you saying that would be a different amount? It would weigh a different amount.
Okay, so the first words that you said were, it's just adding together.
Yeah.
Now, the first words you said I take issue with because in your model, in your definition for atmospheric pressure, when it uses weight and then it uses the word mass as a subdivision of weight, mass is not defined as the...
Who in the background is drying their hair?
Oh, it's...
I barely hear you.
Is it your fan, Tony?
I'm sorry, it's the missus with the hairdryer. Hang on.
It is someone with a hairdryer. Bloody hell.
She stopped now. Right.
I thought it was the Rumpus.
Your words, Rumpus, were it's just adding, right? But the problem is your definition in weight doesn't say masses, it says mass. Now, when we look up mass, we find that the singular is mass and the plural is masses. Now, You're saying it's just adding. Well, if it was just adding, then the definition wouldn't be mass, it would be masses. But it's not, is it? It's mass. So we can't just add because the definition doesn't say masses. Do you understand?
It's your idiotic point. You're just saying you don't believe. Let's just see if you understand this. If I take all the atoms out of an apple and separate them, do you believe they would weigh the same as the original apple? Simple question.
That's not the point on the table.
I want you to answer the question. It will help you to understand what's going on.
Are we saying that the skin of the apple is no longer involved, or is this?
No, all the atoms in the skin of the apple are still there, but they're all separated into their constituent atoms. So I've turned this apple. So we've got 1 apple here, and I've turned into this many atoms. I've separated them all so they're not touching one another, and then I weigh them on these scales again. Do you believe it'll be the same weight?
That's not the correct question to be asking.
I'm asking this question as a first step for you to understand. I need you to understand this point.
It's red herring. The point is...
But nonetheless, do you agree with it?
No, it's an irrelevant point.
Oh my God, so you don't agree with it?
It's a red herring point.
Oh, no. But honestly, Andy, I'm going to take this further, but I need to get you to this first step. So please...
No, I'm not going to that step, Rumpus. You're going to listen to me and stop interrupting.
No, I know. I've listened to you. I've answered your questions, and now I'd like to ask you one. And I want to know if you understand that if I were to take an apple and convert it into all its separate masses, where each atom has a mass... So I'm answering exactly on point of your question. Each molecule and atom of the apple has a separate mass. And I want to know from you whether or not you understand that adding all those atoms together on the scales, separated away from one another, will weigh the same as the original apple.
By making the apple disunited or united, you are changing from plural to singular.
Yeah. But do you accept that the mass of the sum would be the same?
No, that's not.
Oh my God. So in other words, if I cut up an apple and keep on cutting up more and more cut up, somehow the mass disappears somewhere. Is that what you're saying?
If you cut up an apple into all of its molecular points, what you do is change interchangeably between the word masses and mass. And
Yeah, that's your problem, Anthony. You've got a problem with English. I'm trying to avoid your problem with English and trying to get you to understand the physics of it.
I know you
understand that if I separate all the atoms in an apple, it weighs exactly the same. The collection of atoms, which would just be a sort of a mush, will weigh the same as the original apple.
It's not about the weight, Rumpus.
Oh my God. Will you please answer the question?
No, I won't answer the question. You're not.
See what? You see, it's forcing you to think correctly is what I'm doing here. I'm forcing you to understand the issue, which you're dodging by getting mixed up because you can't comprehend English either.
Right. What you're doing is conflating two terms. You're conflating the word mass with the word masses interchangeably, and that's not the definition.
Each molecule has a mass.
You're saying that.
Anthony, I'm tackling exactly your point. Do you understand that each one of these atoms that I've got here, each one of those has a tiny bit of mass, and added together, that forms the same mass as the original apple? Why do you not understand that?
Rumpus, do you understand that when it says mass, it doesn't mean masses?
But a mass is just a collection of mass. When we talk about things like a herd of antelope, we still consist of lots of antelopes, but we talk about the collective term for a herd of antelope as being one thing. It's like any collective term, you then use the singular. But nonetheless, it's got lots of antelopes. So we talk about a herd of antelope made up of lots of antelopes. So we refer to the collective term for that as a herd. We say the herd weighs this much, but they still the sum of the collection of antelopes in it.
But in physics, we refer to mass in the singular and masses in the plural.
Well, no, it's just like a collective term of herd, if you want. Let's call it about the herd. But the point is, Anthony, you should understand the physics. Stop getting confused because you don't understand English very well. Concentrate on the fact we've got these little atoms here. This apple has got so many atoms, this number of atoms. This is the number of atoms in an apple I've got here. Each one, so this is here is the number of atoms. Number of atoms in an apple. It's going to be something like that. In an apple, each one has a tiny little bit of mass. That sum, all those little tiny bits of mass added together, are going to be the same as the original apple.
Well, the problem is, Rumpus, you can't add them together when they're not united in some way.
They're sitting. I'm going to put them, all these little molecules, I'm going to put down here on the weighing scales, all as a separate mush of little atoms. So instead of having, let's just do this one apple at the moment. So here we go. We've got one apple. I stick the apple on here. I weigh the apple. I then convert all the apple into its constituent atoms, and I put that on the weighing machine. They will weigh the same.
It's not about whether they weigh the same. It's about you interchangeably using the word mass over masses because the
term, Anthony. You stop being confused by English, which you don't understand, and think about what I'm saying. Are you saying that if I break up this apple into its constituent atoms, it's going to weigh differently?
No, that's not what I'm saying. You're not listening.
Are you disagreeing with what I'm saying?
Okay, can I just intersect for a second? Is this whole thing going to come down to an argument about the name or the difference between mass and masses?
Correct.
Well, apparently in Anthony's mind, this is incredible. You can't add. I mean, you've reached a new bottom here. You've reached
hold on.
When you can't add.
Hold on, the Rumpus. You didn't see his presentation, did you? So.
I'm dealing with his argument at the moment, which is just insane. He's seen. I mean,
yeah.
he's not
Okay.
quite.
Well, hang on. Just one sec. He did actually address that particular part in his presentation. Tony, perhaps you could bring up the slide that actually deals with that specific point.
But before we do that, Ranty, can you understand what I'm saying? If Anthony's incapable because he's so stupid, do you understand that if I have an apple and I weigh it, and then I break it up into its constituent and then weigh them, it'll weigh the same? Do you understand that?
It's not about weight.
Well, hold on. I want to know, Anty, given the fact you seem to be being very stupid at the moment, I want to know if Ranty understands this so I can see.
I think it all depends on the height that you would be weighing it in your model.
So I don't know. Let's just focus on the question again. I have an apple.
No, let's not.
Apple. Hold on, Ranty. I want to talk to just for a moment, just to Ranty. Ranty, I have an apple. I put it on some scales. I
Yeah,
weigh
but
the scale.
you forget. I
then
don't.
apart the apple into its constituent atoms, and then I weigh again. Do you think those two things will be the same thing?
But can I just
Same.
say that as a moderator, I don't tend to actually get involved in these.
Okay.
Just-
Well, you do.
Just,
Okay, forget
just
them,
so that things are on a level playing field.
Yeah,
So that you can get you. So that,
it's so basic.
hold on, wait.
It's
Just,
like agreeing to
just
1 plus
hold
1
on,
is equal to 2.
just hold on. Just so that you can see Tony's screen, because he's sharing his screen
Yeah,
right
I'm looking
now.
at it. I can
So,
see he's got
so
Amazon
just
pressure.
listen to his point about what he's saying about his presentation, and then
I'm basically having to explain adding. I mean, this is getting ridiculous. I'm having to explain adding to people.
yes, but this is the different. Right.
You're going outside the definition.
Just carry
You're
right.
look,
Tony,
I'm
Tony,
principle
the Rumpus,
here.
please
I'm
give
trying to
Tony.
get-
Whoa, Rumpus.
If I can get, hold on, but if I can establish a principle at adding words, then Anthony can sort his presentation and understand. Think, oh yeah, I've been a bit stupid.
Right, okay. Listen,
Minute.
can you please just give Tony a couple of minutes to do his point, and then you can carry on. It's great. You know, just let him do his point, please.
Okay, so we've had the definition of atmospheric pressure, and he agreed with me that it was the weight of the atmosphere. That is the definition. And when I asked him for the definition of weight, he agreed with me that the weight definition in physics is mass times gravitational acceleration. He agreed with me, and I said I would give you the gravitational acceleration, even though I don't agree with it. For this conversation, I will. The issue is the meaning of the word mass, and I'm contrasting it with the meaning of the word masses, which is the plural of mass. Now, if you want to try and
Just a collective term, Anthony. We do if we say what the mass of the herd of antelope, we just use the word mass. We don't talk about we talk about masses of the individual antelopes, and we talk about the mass of the herd. It's very simple.
If the definition said weight equals masses times little g, then you would be correct. But it doesn't say masses; it says mass.
Yeah, the mass. So it's a collective mass, like the mass of herd of antelope. We talk about the mass of a herd of antelope as one thing. We don't talk about the individual masses of a herd. We talk about the mass of a herd of antelope, and then we say that it's this mass.
Okay, Rumpus. So I cited on in the thingy. Can you see my screen, Rumpus?
Yes.
I just typed in what is the plural of mass, and it says a noun. It says the noun mass can be countable or uncountable, and in our case we can count 14
Yeah, but then
molecules.
you have collective terms, Anthony, like a herd of antelope. You say, what's the mass of a herd of antelope? Do you disagree with that English?
Okay, it says in more general, commonly used context, the plural form will
There
also
we go then.
mass.
So it'll be mass. So what are you what you're getting upset? You're getting involved with stuff you don't understand because you don't understand English. You can't comprehend English very well, and now you're letting it to confuse you. Whereas if you just focused on what I'm saying about apples, it would suddenly become all clear to you, and you wouldn't have to worry about your problems with plurals and collective terms, collective nouns. Anthony, would you say it's correct to say the mass of a herd of antelope is X, Y, I don't know, 2,000 kilograms? Would you accept that was proper English?
Talking, please.
But hold on, just to answer my question, would you agree that it's correct to say the mass of a herd of antelope is 2,000 kilograms?
Rumpus, listen, you've got two choices.
God, you keep on dodging.
Okay, hang on, wait a
Stop
minute.
dodging, Anthony. Answer the goddamn question.
Can I moderate here for a second?
Can you get him to answer my question?
Yeah, I will do when he's finished his presentation to you about this particular point. Let him finish his presentation, and then you two can get into this.
Jesus Christ, I'm having to explain adding. I can't believe this.
Stop talking, Rumpus, and let me finish, and then you can counter. Right. It continues, it says, however, in more specific contexts, and I'll say that physics is specific, it's more specific than general, the plural form can also be masses. Example, in reference to various types of masses, the atmosphere would be a type of mass because it's got hydrogen, oxygen, helium, etc. Or a collection of masses, again, the atmosphere would be so. But I wasn't sure which one to go with, so I looked a little bit broader, and I went to another example which gave me mass, and then plural was masses, and then it gave me different variations of this interpretation from other citations: Wikipedia, Random House, American Heritage, and Macmillan and Cambridge. So I'll just randomly pick, say, the first three. Wikipedia. It says mass.
This is irrelevant.
No, but it's describing them in the...
Anthony, if you listen to my question about a herd of antelope, you wouldn't have to go through all this drivel, and you'd understand the point exactly, and you'd stop wasting your life on this crap.
Not listening. It's talking about them in an object, not in a collection of antelopes.
But an object is a collection of atoms, Anthony. There's no such thing as a single thing, except down to the atomic level. An apple is a collection of masses.
Yeah, but it contrasts that by saying in an object, not in a collection of objects.
But an object is a collection of atoms, you idiot.
It isn't by definition.
It is an apple. It's a collection of atoms.
Yes, that's because it's contained by an apple with
If I took the skin off, suddenly it becomes something different, does it? That's why I said if I broke it down into its separate atoms, it would still weigh the same, and you refuse to answer this question. Is that because you realise it would expose your idiocy?
No, because it's not about the weight, Rumpus.
That's what we're talking about. We're talking about demonstrating
about mass.
Hold on, we've got to get into this first step, which you don't seem to understand, is that if I break an apple down into its component atoms, it weighs exactly the same, and its mass is exactly the same. Do you understand that? And then all to become clear to you, you can sod all these dictionary definitions, and then you will understand. Gone quiet. You've gone. What's going on? Hello? Hello?
I think that's Tony's way of, saying, he can shut up when in the.
Yeah, but he keeps on making the same point, and I'm invalidating it, and he's not listening to my invalidation. He thinks that if he keeps on repeating mass and masses because he's confused, he needs to think, he needs to increase his intellectual activity, and then think, what is an apple? It's a collection of masses. Whether it's got a skin on it.
I have to agree with Tony here. I actually believe there's a chasm of difference between masses and mass.
So hold on.
This is my own personal opinion, and I don't try to get involved. Listen, wait a minute, and I don't just let me finish with what I'm saying. And I don't just. I just want to finish my sentence.
Ranty, hold on. Let me. Why don't you answer the question?
I just want to finish my sentence. To me personally, that is my belief. Now, you guys can argue all you like, but Tony has asked for specific moment of time to actually go through his particular presentation about this, to try and discuss it with you, in which time you can then respond. But what I'm finding is that you're actually... wait a minute. What I'm finding is that you're interrupting him.
Yeah, but he's
demonstrating now is he's demonstrating now that he can be silent. And
but he's not answering my question, is he?
Because you shouldn't be asking a question when he's trying to do his presentation.
And you're refusing to. You're now said that you have a difficulty with it as well. Okay, so now you.
I want is you to be quiet whilst Tony finishes.
He's had 5 minutes, Ranty.
He can have 10 minutes. He can have 15 minutes.
I have had 5 minutes.
Yeah, but you can get that time after he's made his point.
I'm saving everybody in the world in particular.
Listen.
But if you just think of this little problem, it will bring a clarity to your brain.
As someone who speaks English very well myself, I do know that there is a massive difference between masses and mass. Now, there isn't. There is. There is. Now, I'm not going... Listen,
Ranty,
as the moderator here, I'm not going to get involved in this. I'm not going to get involved, except for to say that it is well known that there is a difference between the two. So,
Ranty,
Tony,
do you understand that an apple is a collection of masses?
I will have to say to you here, the Rumpus, right? Seriously.
Do you understand an apple is a collection of masses?
I can't stand by and listen if you're going to try and misrepresent these two words.
You're not letting me speak. Ranty, do you understand an apple is a collection of masses?
Listen to me, the Rumpus.
You're not answering, so you're dodging the question like Anthony.
Trying not to get involved. Dodging. But what I'm saying is that I do understand there is a difference between these two words.
Do you understand an apple is a...
I want Tony to do his presentation and then you to listen to this. You need to have some restraint.
I've made his point. He goes on about masses, and I've got invalidation, which is not listening.
You need to have some restraint here, seriously.
I have restraint. He's had 2 or 3 minutes at it, and he keeps on making.
No, he can have 10 minutes. Let him have his. He's
had
point.
5 minutes, Ranty.
He can have 20 minutes.
5 minutes. Yeah, but the point he's making, with one question, I can invalidate it, and we can all move on.
We can move on to that once he's done his point.
The same stupid point.
You still don't understand. The time that we've spent arguing over this.
So why don't you let me finish my point and answer my question? Why don't you answer my question?
Because it's not my debate.
Well, okay, then
I'm the moderator. And I'm just
quiet then.
Well, I want you to be quiet.
I have been quiet.
Be quiet till he's finished. Let him say he's finished.
What? Okay, what's he got to finish to say? He's
I
got
don't
his
know,
picture
because
again.
you haven't allowed him to get to that. So let him get to the end of that.
Okay, well, when I get my turn, then I will get 2 or 3
You will
minutes.
get your turn. You will get your turn, Rumpus. You know that.
What a waste of time this
You
is.
will get
I
all
can't
your
believe I have
turn
to
in the
explain
world.
about adding.
You will get all the time in the world.
1 + 2 next.
The Rumpus. Please put yourself on mute. Tony, you carry on, my friend.
Right, Rumpus, listen, I've got better things to do with my time at the minute, so just let me
Certainly have
finish.
been studying this bollocks, yes.
All right, so atmospheric pressure, according to the Indiana State University and according to Blue Marble Science, and I agree with both of them, is defined as weight over unit area. Now, we've agreed that weight is mass, bloody hell, weight equals mass times acceleration due to gravity, right? We've agreed with the gravity. Mass is not defined as masses, but once we've got the weight bit sorted, which we can't get sorted, but once we get that sorted, we've got a problem with the unit area as well, because the unit area is defined as an area of a surface. Well, we don't have any surfaces either. So even if we can get to a conclusion on the weight point, we can't get to a conclusion on the unit area, because unit areas are based on surfaces. They're not based on imaginary lines in the sky. So you can have the rest of these time Rumpus. I'm kind of done because you can't get past these points. You can't satisfy your...
I've got to get. I'll move on to this one. You don't basically understand what pressure means, it seems to me. Anyway, so we'll deal with pressure in a second. Right, so my question to you, Anthony, is do you understand that an apple on some scales will weigh a certain amount, and if I cut up that apple into tiny, 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 tiny pieces, that it still weighs the same? Do you understand that?
Yeah, it's not about that.
I know, but do you understand what I just said?
Yeah, I do, and that's not...
Now, let's suppose I reduce that not just to tiny, 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 tiny pieces, but down to the constituent atoms. Do you accept that also still weighs the same?
Yeah, but that's not the point.
I know, but you let me develop my argument. I've let you develop yours. I'd like you to let me develop mine. And I need to take you on your journey.
It's pretty fair. It's pretty fair if you let the Rumpus develop his argument. I do agree. Go ahead.
Right, so, thanks, Ranty. So, Anthony, do you understand then if I reduce an apple to its constituent atoms, it will still weigh the same on the scales?
I agree.
Brilliant. Right, so just because we referred to the mass of the apple, it's actually made up of the masses of all the constituent atoms. So this idea you're getting confused about with dictionaries about masses and mass is utterly irrelevant.
It's not, Rumpus, it's contained by the apple.
If you understood the principle, hold on, Andy, you just said you understood that all the constituent masses of the molecules add up to the same mass of the apple. Therefore, there's no difference between
You also
the masses
said that that's not the point in contention, Rumpus.
Well, it is, because you got confused about masses and mass, and I've just demonstrated there is no problem.
You know when you said about the herd of elephants, or whatever it was?
Antelope, yeah.
Yeah, the herd of antelope, right? If it says mass, that means one antelope.
No,
if it says masses, it means the herd.
No, if I say the collective term for an antelope is a herd of antelope, and I talk about the mass of the herd of antelope, because you've used a collective noun. A herd is a collective collection of antelope.
Use proper English.
Let me finish my sentence. So when I say the mass, I use the word singular there because I'm talking about a collective noun, which is a one noun that describes an arbitrary number of antelope. Therefore, I talk about hold on. I therefore talk about the mass of the herd. Do you understand the use of the collective noun there? And therefore, the mass of the herd is correct English.
Is the definition of atmospheric pressure a collective noun, or is it a noun?
I'm just going to read out what I've put into Google. Is there a difference between mass and masses? So, a mass of things is a large number of them grouped together. A mass of something is a large amount of it. Masses of something means a great deal of it.
Yeah, so the point is, so moving on from the apple scenario, which you've accepted, that if I take an apple and I break it up, I talk about the mass of the apple, but then I talk about the masses of its constituent parts, they sum to the same thing. So there's just like a herd of antelope, is the mass of a herd of antelope is the same as the masses of the sum of all the antelopes in it. There's no difference. Similarly, the mass of the atmosphere.
There isn't.
Hold on. You haven't. I've only had 20 seconds. And the mass of the atmosphere is the sum of the masses of all the molecules in the atmosphere.
Oh, it isn't.
Oh my God! You see, you can't add, can you? It's unbelievable. I'm having to explain about adding.
It's about distinguishing and
The
recognizing.
atmosphere is a collective noun, Anthony. The atmosphere is a collective noun, like herd. So when I talk about the mass of the atmosphere, it's the mass. It's the individual masses of its components added together form the mass of the atmosphere. I mean, this is like talking to a 5-year-old. This is unbelievable. You really have reached a new low here.
Okay, so the title of this Roundtable 26 was Atmospheric Pressure Does Not Exist. Is there a way that we can get to this point?
Well, okay, so having established that the mass of the atmosphere is the sum of the masses of the individual molecules, we can then go on to this diagram that Anthony's now got on.
That's a lie, Rumpus. It isn't the adding of all the masses. It's one mass.
Yeah, and it's you understand the constituents of it are the molecules in the atmosphere, don't you? So the mass of the atmosphere is the sum of the masses of all the molecules in it. How can you not accept that?
Because it's not a collective noun the way you were misrepresenting it. It's a noun.
Whatever. Let's just avoid the collective. Do you agree that the mass of all the molecules in the atmosphere, I can say that's whatever you want to call that, the collective noun of all the molecules in the atmosphere equals the sum of all the component molecules?
That's not the definition.
The atmosphere is the collection of everything that's in the atmosphere. It's a collective noun of all the constituents in the atmosphere, Anthony. I mean, you don't understand English. This is ridiculous. It's like talking to someone who hasn't got English as a first language. Jesus Christ.
That's the definition.
So you're saying then that you do not accept that the word atmosphere refers to all the components in the atmosphere? Is that what you're saying?
Yeah, I agree with that. But that's not the definition.
That's right. So the mass of the atmosphere, which is a collection of all these things in it, is the mass of the sum of all of its components.
It's not the collection of it, otherwise it would be called masses.
Oh my God. It's a collective term, you twat.
It isn't. It's a singular.
Someone who can't understand English. This is ridiculous.
That's my point, Rumpus. It's
mass
not.
Of the atmosphere is the sum of the masses of all the molecules in it. How can you dispute this?
Otherwise, it would be called masses, Rumpus. You can still see my screen.
It's a collective term for everything in it. I mean, if you're not meant to, I described a herd. The mass of a herd of antelope is the sum of the masses of all the antelope in it. I mean, this is getting to the point where you're so stupid. You actually, I know you use stupidity as a shield against reality and science, but this is taking it to the point where you're using it as a shield against understanding basic English. I mean, this is just incredible. I mean, a 5-year-old would understand this concept. Herd of antelope, the mass of a herd of antelope is the sum of the masses of all the antelopes in it.
Thankfully, I think the audience can see the issue. Regardless of the Rumpus misrepresenting that I don't see it, I absolutely do see it. And I think the audience can see it too. The definition of mass is different from the definition of masses. Mass is a singular, masses is a collective. Rumpus is using them interchangeably. That's the reason why they can't satisfy the definition.
Okay, Anthony, what do you want to call, Anthony, what do you want to call, if you add up the masses of all the molecules in the atmosphere, how do you want me to describe that?
Okay, so listen, this argument is about what in particular?
It's stupidity. We're arguing about stupid.
I need a definition, the Rumpus, which you are arguing for masses against mass in a particular sentence in what you are arguing about now.
I'm starting.
I don't want it to be an antelope. I don't want it to be an antelope. I don't want it to be a sun. I want to know about what it is about the atmosphere.
But Ranty, if he doesn't understand that the mass of the atmosphere is the sum of all the individual molecules of the atmosphere, then we've got a big initial hurdle to get over with.
Oh, I see. So you've interpreted it to include molecules I see. So molecules as in the atmosphere, right? Okay. So basically, what you're saying is, because I've got a definition up here. Just bear with me. Wait a minute.
That's why I asked him to give a citation, not a calculation.
But this is English.
Yeah.
It's like saying the antelope thing, herd of antelope. No, there's no definition out there that the mass of the herd of antelope is the sum of the masses of herd of all the individual antelopes, because it's so so bleeding obvious to anybody over 4 that no one needs to bother. You don't. There's no science, a bit of science that does this because everybody just assumes you understand how to add.
I just want to say that whilst you're speaking there, the Rumpus, Tony doesn't get a word in. For some reason, your mic well overpowers him, so everything you say is heard and everything that Tony says is not heard. But what I'm saying is that you want to try and tag in molecules to the atmosphere. You could have done atoms, you could have done anything, but you want molecules, you want...
Well, no, molecules and atoms. In other words,
but what I'm saying is...
The total mass of the atmosphere, all I'm saying is the total mass of the atmosphere is equal to the sum of all its constituents, i.e. the molecules and the atoms and the dust that's in there as well, but it's the sum of all those things together that give you the collective mass of the atmosphere.
Okay, Sleeper, so the Rumpus, can you just go on mute for a couple of minutes, just let Tony have a response?
Well, I never had my 2 minutes, did I?
Yeah, but you've made your point.
Yeah, so... no, well, I haven't been able to have my 2 minutes. I'm trying to answer this next point that he's got about his pressure, which I was going to get on to.
Well, before you get there, though, I'd like to hear Tony, because every time you speak, you overpower... Your mic, for some reason, overpowers Tony's, and we don't get to... I haven't heard Tony speak for the last 5 minutes, so...
Ranty, that's why when Rumpus first joined, I asked him for a citation. If you listen back to it, I asked him, and I contrasted against calculation because his claim was that masses were able to be used. And I said, I want you to give, because he said the sum of the masses. And I said, I want you to give citation for that, please. That's the point. And he's gone round and round and round and round and round.
Anthony.
And we haven't got a supporting citation from him that masses means mass, and that's ultimately where it is. And if you can't provide it, Ranty, I win.
I can listen. Guys, listen.
You're denying that adding works.
Be silent, people. Right. So I've just typed into into Google. I typed in the mass of the sun is the mass of all the masses in it. So when I go to solar mass, it brings up. Hang on, where are we? The solar mass is a standard unit of mass in astronomy equal to approximately so many calculations. It is used to indicate the masses of other stars. So the solar mass is used to indicate the masses of other stars. So there is a citation here that sort of brings the two together. But what you need to do in that is you need to... there has to be differences between each thing. So when I was speaking to you before and I was saying about you wanted to bring molecules into the atmosphere.
Of course I do. It's made of molecules. That's what makes up the atmosphere.
You could bring everything into everything is what I'm saying.
But I went initially. I started off with apples. I talked about the constituent of an apple is a collection of all the apple atoms and molecules to try and get Anthony to understand what an apple is and what its constituents are. And each one of those constituents have a mass. So it's a collection of all the masses of all the atoms and molecules in an apple form the mass of an apple.
What I'm saying is there is a citation that does that, Tony, but on the other side of the coin, what I would say is that you could interpret that and bring anything into that about how many fleas are on a horse. I mean, you could literally bring it to that kind of level.
Yeah, this is why I don't understand why Anthony can't understand it. It's so simple, it's so basic, it's so 3-year-old.
Right. Mass is a singular noun. Mass is
collection. It can be, and when you have an object, unless you go down to the resolution of a quark, everything is constituents of something else. So the atmosphere has molecules in it, the molecules have atoms in it, and the atoms have quarks in it, and the quarks have mass. So you can go by layer by layer by layer. Everything is a collection of everything else.
Down any further than the molecules of the
Well, the mass, friends. Let's take an oxygen atom. It's O2.
Question: can you reduce the molecules down any further than the molecules?
Yes. Because the mass of the molecule is the sum of the masses of the atoms in an oxygen molecule, and what's more, an oxygen atom is the sum of the masses of the quarks in it and the electrons.
All right, let's go with that.
Every time you can break it down further and further. Everything, Anthony, in the real world.
Okay. We get the point.
I've got to make a major point here. Everything in the real world is a collection of something else.
Rumpus, listen to me, please. On screen right now, can you see my screen PowerPoint?
Yes.
Right. I'm showing different molecules that are in the air. Some of them are similar to others. Some of them are different. Some of them have got 3 molecules together and they're bonded with bonds. Some of them are singulars. When we've got 3 of them bonded together, we can cite that as 1 molecule. Or when we have the singular, we can count that as 1 molecule.
No,
because it's the unified collection of them all together that makes the mass.
By definition, a molecule is more than 1 atom. If you've got an atom by itself, it's an atom. It's not a molecule. You don't understand basic chemistry. But Anthony, do you understand that green thing you've got there, whatever that might represent, argon or something? Do you understand that is a collection of quarks and protons and electrons? It's a collection of other things that have mass. So this object here, this atom, the green thing, was just by itself. It is a collection of other things that have mass, and its mass is the sum of its component masses.
So the atmosphere, Rumpus, is filled with different molecules.
Yes.
And the problem that you've got is that you need them all to be unified to give you a weight, but they're not unified, Rumpus.
Don't need that at all. Absolutely do not need that at all.
Hey,
Why
well,
I need that?
Otherwise, Rumpus, all of your molecules are acted on by gravity individually.
Yes, they
You
are.
need the collective, and you can't have them
Not individually.
collected.
They're all acted on individually. Of course they are.
Yeah, they're all acted on individually, yeah.
Yes.
But you need them to be unified, otherwise you
don't.
don't have a collective weight.
No, I don't. Yes, you do. You have collective weight whether they're stuck together or not.
No,
They
you
have
don't,
collective-
because if
Anthony,
they're not
if you
together-
add up the masses of all the molecules you've got on screen at the moment, that's the same thing as if they were stuck together. The mass is the
No,
same,
it's
you
not.
idiot.
This when they've got 3 together, that will be classed as a mass because it's bonded. But when you've got 9 of them and they're not stuck together, that would be the
The mass
plural,
is no
the
different. The
collective
mass
noun.
is exactly
and
the same,
not-
Anthony.
So what that
The
means,
collective
Rumpus,
mass of those molecules is the same. Whether
So
you
it
break them up.
that is Rumpus. Listen,
Anthony, look, you dickhead! If you broke up all those molecules into their separate atoms, they'd weigh the same. It doesn't make any difference, you moron.
and then it would be
Jesus
collective
Christ.
nouns, Rumpus, wouldn't it? They're not collective nouns in the definition.
Anthony, do you understand if you separated those molecules you can see on screen now into their separate bits, so you made them all one, they would
Collective
weigh
noun.
the same? Do you understand that?
You would have a collective noun and be outside the definition.
Do you understand that if I were to break up all the molecules you've got on screen at the moment, it would still weigh the same?
It would be a collective noun and outside the definition.
Do you understand that the weight of all the things, if I were to break them up into the separate atoms, would be the same?
It would be a collective noun and outside the
Do
definition.
you understand that if I broke up all those molecules into their separate components, it would still weigh the same? The weight would not be any different.
It would be a collective noun and outside
Who
the
cares
definition.
whether it's a collective noun? Do you understand it would weigh the same?
It's outside the definition.
That's a different. What are you talking? Do you understand that the weight of that would not change whether they're touching together or they're combined in those molecules? If I separated them into their separate atoms, do you understand that the masses and weight would be the same?
It's not about the weight, Rumpus. It's about whether you can use mass as a collective noun or whether it's a
that's your
singular
problem
noun.
in English. Is the weight of those molecules you had on screen the same whether they're together, bonded together? For instance, if I were to stick them all into one lump.
It's not about the weight.
Hold on. Well, what is okay? The mass then, whichever one you're talking about, the mass or the weight. Do you understand? If those were all in one clumped together thing, it would weigh exactly the same as if I turned them all into separate atoms.
It's about whether it's a collective or whether it's a singular.
Yeah, so right. So are you accepting that the collective is the same mass whether or not they're separate or together?
It's not about the weight, Rumpus. It's
Well,
about
what is it about then? You were talking about mass and weight. That's the subject under
It's
discussion.
about you can group them all together the way that you are and treat it as a collective noun, or whether
No,
they
we're
are
talking about
separate.
the mass, Anthony. We're talking about the mass and the weight of these objects. That's the subject under discussion. Are you saying it's changing whether or not they're stuck together or not?
Stop over talking me, please, Rumpus.
But you're not answering my question. You keep on dodging it. If I stuck all those together, would it change the mass and the weight of the things we're looking at?
Your question is
Oh
not.
my God. You stupid.
It's a red
bastard. I mean,
herring.
you cannot be this stupid. You've got to be willfully being stupid here.
No, Rumpus, your question that you're asking is not the definition. I'm trying to apply.
Definition of what? We're talking about
don't
mass and weight.
do it.
That's the property. Anthony, we're talking about the property of mass and weight here. That's the subject of discussion.
We're talking
And
about
you
the
seem to be disputing that the mass and weight will be the same.
definitive.
I didn't hear what you said.
Yeah, one at a time, please.
But this idiot at Ranty, can you ask him to answer my question whether or not he thinks that if I were to separate those molecules and the atoms he had, whether it would weigh differently, whether I stuck them all together in one lump, or I separated them out into their components where they had the same mass and weight. Could you ask him that? Because he won't answer me.
Okay, so Tony, could you answer that one particular question and then ask Rumpus a particular question, and I'll expect the same from him, which will be a response.
3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There are 13 globules, molecules of gas. If you were to add them all up, you get to 13. If you were to split them all into their individual atoms, you're still going to get the same weight, but that is not the
Hey, excellent. Well done. We got somewhere.
No, not excellent.
Let him finish, Rumpus.
Right.
Excellent, well done. The question is, Rumpus, to satisfy your definition for mass, you need to apply a plural. You need to apply a collective noun. The definition of mass is singular, and you can't do that. Therefore, you cannot satisfy your own definition because you must rape the meanings of words. That's
Not at all. The question is, if I were to ask you, Anthony, how you'd work out the mass of the atmosphere, how would you do that?
That isn't the question.
I'm asking the question. Would you please answer it?
The question is, Rumpus.
How about answering my question instead of dodging it? Yeah, and I'm going to lead you on to the answer because you're asking stupid questions and I'm asking sensible questions. And by answering my sensible questions, you'll begin to understand what you're doing wrong. Because me explaining things to you isn't working. Only by you asking you questions and you answering them are you going to get to where you need to get to.
Well, that's what a debate's all about. A debate is about asking a question, getting a response, then you getting the chance to ask a question and respond back. I mean, that's fair enough.
So, Anthony, could you please tell me how you would go about measuring the mass of the atmosphere?
Auntie, I've made my point, and I don't need to be here anymore. Rumpus can argue with himself.
Yeah, you're dodging it again, Anthony. You see, you just dodge and deflect, don't you? You don't like it when I expose your idiocy.
No, it's not that I don't like it.
It's a simple, reasonable... It's not an abusive question. It's a simple question that I think a 5-year-old would be able to understand, knowing that the atmosphere is made of molecules and atoms. And I'm asking you how you would go about measuring the mass of the atmosphere. What would you do? How would you think you'd go about that?
Well, I would look up the definition of mass. I would accept that it's not a collective noun. It's a singular. I would then find out what mass you're referring to in the atmosphere.
The mass of the atmosphere.
I would then reference that mass because mass.
So what is the mass? I want you to give me a procedure for telling me what the mass of the atmosphere would be. How would you do that?
Rumpus, listen. My conversation with you is over.
Simple question.
I don't need to go any
You're
further.
dodging it. Not exactly. So you're dodging it. You don't want to think. You do not engage your brain, do you? Because you think it'll seize up and short circuit. It's a really simple question, Anthony. A 5-year-old could get this.
Hang on. Whoa. I'd like to hear Tony because the Rumpus. No offense, mate, but every time you speak, you cut Tony off.
Okay, go on.
This is my final sentence, Rumpus, and you can either ignore this, or you can argue something else, or you can actually answer it.
You can dodge the question.
Your atmospheric pressure requires mass. It's clearly a singular noun. It's not a collective noun. I know you want to use it as a collective noun, but otherwise, if you did use it as a collective, it would say mass and then in brackets masses. It doesn't say that though, does it? It just says mass. So mass is a singular.
The mass of the atmosphere.
Using it incorrectly as a collective noun, and that's why I say that you can't satisfy the definition, and therefore your atmospheric pressure does not exist.
How would you get the mass of the atmosphere, Anthony?
Okay. So basically, you don't want to address the point I've made.
I'm addressing it because you're confused about the mass and masses, and I'm just demonstrating to you that you use the collective term. The atmosphere is a collection of all the separate masses, like an apple is a collection of all its separate masses. Like that picture you had is a collection of separate molecules. And if you had...
Well, the Rumpus, please. You know, Tony's trying to speak and you're just cutting him out.
Yeah, but hold on, but he had a turn. I thought it was my turn.
Ranty, listen, I'm going to conclude and go because I don't need to go any further. Rumpus ignores the fact that it's singular. He needs it to be collective so that he can argue.
The atmosphere is a singular
thing, so Tony, what's the question?
How many atmospheres are there, Anthony?
Wait a minute, so what's the question?
Anthony, how many atmospheres are there?
What is the question that you would like
Hold on.
What is the question that you would like?
You ask him how many atmospheres there are. There's
one,
is
the question,
and that has a mass.
What is the question that you would like to leave the audience with there, Tony?
Okay. I would like you to ask Anthony how many atmospheres...
Hang on, Rumpus, you keep interrupting here. Let Tony say what he says.
bit here. Air is not mass. Air is a mixture of masses. The only mass that gravity can act on in their nonsense model is the individual molecules in isolation. There's no cumulative effect. There cannot be, as there is no mass. Only individual masses. A lack of molecular bonding means that the mass is simply the molecule, and therefore there can be no real weight, only pressure.
What's the molecular bonding got to do with mass? It's completely irrelevant.
Well, the molecular bonding is important because if you've got, see these 3 atoms that are here, there are 2 bonds that join them up to create a unified,
you think that changes the mass, do you?
Molecule, and that allows you to call that a mass.
So,
but when
it's just a problem you've got with collective nouns. But what about the collective
Hold on, one at a time, please, Rumpus.
Well, he's made his point. I'd like to.
No, he hadn't made his point. Let him finish.
So when you've got 3 atoms together that are unified as one particle or one molecule, then that's called the mass. But when you haven't got the bondings, then you've got numerous masses, but you don't have the unified mass that you need to satisfy your definition, Rumpus.
Anthony, if I were to ask you to give me the sum total of the mass of all the things we can see, could you do that?
Not interested.
How would you go about doing that?
The definition.
I want to know the mass of what you can see on screen, please. How would you do that?
On bed, mate, because he's not addressing the point. He's making up bullshit red herring.
I'm asking you, how would you give me the mass, the single word mass, for the collection of things we can see on screen?
I'd like... Oh, he's gone.
It's unbelievable. I mean, this is stupidity on a scale I didn't think was possible. He doesn't understand how to add things up. He doesn't understand what we were looking at, that photograph or that image was a collection of different atoms and molecules. And then if I wanted to know what the mass, the singular term for that collection, is by adding up the component masses of all the things you could see. I mean, this is something, I mean, my frustration maybe, you might be regarded as unreasonable, but I mean, Ranty, you can't be this stupid. Surely you must understand that if I wanted to know the mass of that image that he just had on screen, you would add up the masses of the component things you could see. I mean, surely you understand this. Oh my God! Don't tell me you've got this as well.
I want to. You're
telling me you do not know how you work out the mass of that collection of molecules. You don't know how to do that.
No. What I'm going to do is I'm going to share my screen.
Unbelievable.
Can you see this, Rumpus?
Yeah. Yes, it's something to some bloke with a thingy. Yes.
Yeah, I'm gonna leave you with this. So, it was something that I spotted today, actually.
But Ranty, how about answer my question though? If I were to ask you how you work out...
Yeah, but hang on, wait a minute. Again, this isn't my argument. This is what I don't do this on these shows.
Well, you did.
You know this. You know this. Well, there is a difference between mass and masses. You know, I mean, there's no denying that there is two separate words.
The sum of the masses. Do you understand?
You know that there are.
Ranty, I'd like to ask you a question, please.
Yes, but there are 2 separate words.
And yes, but do you understand that the collective mass of the things we were just looking at in that diagram of Anthony's, those molecules, they are made up, it is made up, that singular collection term, the collective noun of the mass of the collection there, I dearly hope that you would understand, you would add up the masses of the things you could see, because there were 13 molecules, but each one there was separate. There was another several had were molecules of multiple things, and hopefully you would understand that the way to get the collective singular mass would be to add up the masses of the components. You do understand that, don't you? Oh my God!
So the Defiant Forest. This was
How can people be this stupid?
This was an...
Carry on. Okay, you just exposed yourself as an idiot to everybody who's watching this, but anyway, carry on.
No, not at all. This is Roundtable 26. This isn't my presentation. Everything that is talked about on this is owned by the person that actually does the presentation.
You expressed an opinion.
Only because you guys were arguing about 20 minutes about the difference between the single words mass and masses, right? And I had to intersect for the sake of the audience there, which they are 2 separate words. Whether you bring them into something different is entirely your argument, but that needed to be spoken about, and I did that.
Well,
I interrupted for the sake of the audience and myself, because essentially I was going around the bend listening to you guys argue about such nonsense.
It is not, absolutely. The fact that he can't add up is just incredible. I mean, he's just amazing. He doesn't understand that the mass of a herd of antelope is the sum of the masses of the individual antelope. I mean, if we can't even get to that point, I mean, he thinks he's entitled to lecture people about things like pressure and atmosphere when he can't even add up. I mean, it's just amazing.
Can I leave you with this post? This is a Facebook post. It's a very interesting one, actually. In 1960, David Latimer planted a tiny garden inside of a large glass bottle, and he sealed it shut. He opened the bottle 12 years later in 1972 to add some water, and then sealed it for good. The self-contained ecosystem has flourished for nearly 60 years. For those who are wondering how this is even possible, the garden is a perfectly balanced and self-sufficient ecosystem. The bacteria in the compost eats the dead plants and breaks down the oxygen that is released by the plants, turning it into carbon dioxide, which is needed for photosynthesis. The bottle is essentially a microcosm of Earth. And if you have a look at this image, here we have this guy with the ecosystem that he's made. 60 years he's planted it inside of this bottle. Don't you think that's a wonderful image?
Yeah. Nice, interesting. Yeah.
Noticed how it's contained?
Yeah. Well, otherwise, the whole point of this is trying to point out that that there's enough resources in there to sustain. Doesn't require any external resources, except the sunlight, of course. That's the thing. It's not. It's got energy going into it, but yes. So okay, well we know that.
It's interesting that they say that it's essentially a microcosm of Earth.
Yeah, well, the vacuum of space is acting like the bottle, insulating it from the outside world.
The vacuum of space is an insulator, did you say?
Well, it stops. In other words, it means there's very little material that's moving in and out. But there's no physical. I mean, the whole point about the Earth being a closed system is there's no material exchange of matter in and out, just energy. So a closed system allows energy to come in and out, like is happening here with the sunlight. But it's a closed system in the sense there's no material coming in and out. I mean, there's so little on the Earth so we're a closed system. That effectively that barrier of the glass there is exactly like the barrier of the gravity caused by gravity, because the gravity of the Earth contains everything and it doesn't let it get away. So that glass is effectively acting like gravity.
So is gravity a barrier?
Yeah, stops. That's why you can't. That's what stops you leaping off into space, Ranty. The gravity, the force is pulling you down, just like the molecules of our atmosphere.
How does a space rocket get out into space then?
Well, because it fights against the force of gravity, but that's only because you have to put an enormous amount of effort into it. But molecules and all the atoms that make up this planet do not have a rocket attached to them, so they stay stuck on the planet, just like you do. You can't escape Earth, can you?
But isn't gravity a barrier?
Yes, agree. Yeah. Well, yes. On certain things, I mean, for instance, hydrogen goes so quickly that it will escape the Earth. There are some things that can escape the Earth's gravity, but most of the things can't. Rockets can escape. Hydrogen can escape, but almost everything else can't.
So are humans rocket and hydrogen?
That's right. Yeah, hydrogen.
That's all humans are. Is that what you're saying?
No, I said again. The only things that can escape Earth's gravity are hydrogen, helium-3, and possibly I think possibly some bits of volcano. Probably not actually. So just hydrogen, helium, and man-made things that have got rockets attached to them.
You mean the only gases that can escape?
Yeah, solids. There's no solid. Just like you can't escape because you're solid and gravity pulls you down. You can't escape the Earth because of gravity. Similarly, the gases. There are only some things that can escape the Earth, and that is hydrogen and helium. Everything else is too dense. I mean, some of them might. I mean, occasionally, what might happen is that an oxygen molecule might get bashed by a very powerful solar piece of the solar wind and then get enough energy to go, but that's very unusual. If we go with the sort of 99%, which is in what science you always have, nothing's completely fixed in science because strange things can happen, but 99.9% of there's the 99.9% of the things on Earth remain on Earth because of gravity, but there's the little bit of hydrogen, helium, and maybe the odd other bit of gas that can sneak out. But for instance, you can't get out from the Earth because of gravity. That glass container there is just like gravity containing the Earth, and that glass is doing the same thing.
So, can you just confirm for everybody that gravity is a barrier?
Correct. Just like you can't escape the Earth because of gravity. Correct. There's a gravity for almost everything.
No, I'd like to hear you say that. It'd be nice.
Well, there are always exceptions to the rule, and this is what you get confused by. You can't understand the nuances. For hydrogen and helium, it's not a barrier, and for man-made rockets, it's not a barrier. But for everything else, it is a barrier. It's also not a barrier to light, but that's.
Can you say it's a force field?
Yes, gravity is a force. Yes.
Is it a force field?
Yeah, gravity is a force field. Yes, it's a field that generates a force on things with mass. If things do not have mass, then it's not a force field. It's a force field in that it acts on things with mass. So light, for instance, can escape the Earth, but things with mass, like you, like this chap, like that bowl, can't escape the Earth without being stuck on a rocket, because gravity acts like a barrier to almost everything. Not absolutely everything, because no doubt you're going to go away from it and say, oh, look, he said it was a barrier. But you're not going to remember that I said it was a barrier to almost everything, bar man-made rockets and hydrogen and helium. You're going to go away and say, oh, no, he said it was a complete barrier, yet we've got rockets. Oh, my God, Rumpus was wrong. And you're not going to remember my qualification that I just gave, that with exception of rockets, exception of hydrogen and helium, it is a barrier. But you're going to forget what I just said, then, aren't you? You're going to come tomorrow, you're going to reset, and you're going to think, oh, Rumpus said it's a complete
No,
barrier.
I just want to qualify. I just want to qualify exactly what when this guy made his ecosystem 60 years ago and it's flourishing inside a barrier. I just want to know what you qualified as being a barrier.
What a barrier to energy? It's a closed system. So do you understand what a closed system is?
Of course I do.
Okay, what's a closed system?
Well,
then?
apparently you have an open system.
No, the Earth is a closed system.
Oh, so it's not an open system?
Correct.
Right,
I mean,
okay.
in order to, again, this is because you don't understand things. In practice, it's a closed system. Although things can escape, like the things I just mentioned, rockets, hydrogen, and helium can escape, and obviously we have some odd things coming in. But because that forms such a tiny, 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 tiny proportion of the Earth's mass, we ignore it in atmospheric sciences and say it doesn't matter, we can forget about that, doesn't matter, irrelevant. So for all, in terms of in practical terms, we can forget about these things and call it a closed system. But
Okay.
You won't remember that.
I remember this, but
you'll say tomorrow, you'll go to Andy and say, oh look, Rumpus said it was a closed system. How does he account for rockets? Because that's left in it. And how does he account for asteroids? And then you'll forget that I qualified it by saying, in practice, it's a closed system, because you'll forget that. And you'll say, oh, how does he account for rockets?
Can I just ask you, a couple of years ago when we had this argument a couple of years ago, and you was very adamant that it was an open system.
No, you got me confused with someone else. You've
No.
misremembered it.
This was a couple of years ago on Nathan's debates.
Just remembered it.
No, I've remembered it for the longest time. In fact, it wasn't just you. It was there was Gem Panda.
Yeah, and we all agreed it was well. I'm not the thing. Was some people who think
it was no open system back then.
You have misremembered as you usually do. You've got the memory of a goldfish.
Listen, this isn't.
Misremembered it, Ranty.
No.
I've never changed my position. The Earth is a closed system in terms of. I mean, just because one molecule of hydrogen escapes, you could argue, well, that invalidates the closed system. But in practical terms, it is a closed system, which means that energy can come in and out, like lights from the sun. But because what comes in and out is so small in comparison to what's there, in practical terms, and from the point of view who worry about these things, like atmospheric scientists, they're going to say it's a closed system. But it's just as I predicted. You're going to misremember tomorrow what I've said, and you've clearly misremembered what I said.
How can you say what I'm going to misremember tomorrow when it
because
hasn't
I know
even
what you're going
happened?
to do, Anthony. I know you're going to say tomorrow, oh, Rumpus said it was a closed system. And so how does he explain rockets, you're going to say to Nathan? And Nathan's going, oh, yeah. Well,
Why is it? Wait a minute. Why are you bringing Why are you bringing? Wait a minute. Why are you bringing Nathan into this? This has nothing to do with Nathan.
I know what you're going to. You and Riley are going to say. Rumpus said it was a closed system. Ah, how does he explain rockets? And you'll forget.
Listen, if they want to say that, that's entirely up to them.
No, you're going to say that. No, that's what you're going to say. I know what you're going to do because you've done it.
Why am I going to say it?
Because you're an idiot. Because you have the memory.
It's either closed or it's open. You can either come in or you can leave it. It's one or the other, surely.
Yeah, but you'll misremember my qualification. You will not remember that I said.
So it's got caveats on it.
Yes, you'll forget that because you always forget it.
So okay.
Just like you've forgotten what I said 2 years ago about it being closed system. You now think I said it was open when I didn't.
You did actually say it was an open
tomorrow,
system.
No, I didn't. And tomorrow you're going to say, whoever you'll speak to, you'll say, he said it was a closed system, but how does he account for rockets? Rockets make it an open system, you'll say. And you'll forget to me saying, well, in terms of practical terms, because a rocket is so small in comparison to the mass of the Earth, we can regard it as a closed system. And you'll forget that. And tomorrow you'll forget I've put that qualification, and you'll then talk about rockets and how wrong I am because I called it a closed system. But I know that's what you're going to do. It doesn't. I mean, I just know that's what you're going to do. It's not going to particularly upset me. But I'm just thought you might like to know that I know that's what you do. Whether you do it intentionally or not, or because you're stupid, or you do it intentionally, doesn't really matter. That's what you will do.
I'm just laughing at how you can actually speak so many words in like a second. It's crazy. But yeah, I mean, good stuff. I mean, thank you for coming. The chat's going wild here, saying that they're going to have a field day with this tomorrow, which is, it's what it's all about, isn't it? Really, I mean, let's get this, let's get this out there. Let's have this argument. Let's see where this ends up. Yeah.
Yeah. Okay.
Seriously. I mean...
I don't know what you mean. Well, it won't end. You'll still be confused and ignorant, just like Anthony. I mean, he couldn't face the questions. I mean, the fact that... I'm a bit shocked today. The stupidity...
Hang on, you can't call him out when he's not here.
Oh, I can.
No, you can, but it's really not fair because he actually did leave. It's getting late and, essentially...
That's true. Yeah, okay. But he left... Yeah, but he didn't leave because he was tired. He left because... I think basically his brain was... I think at some deep level he understood that there's a problem with what he was saying. The fact that the collection of molecules he was looking on screen and how he would... the fact that he dodged the question, and even on a couple of occasions when I made you asked you to ask him questions, he did actually give the correct answer. So deep down, I think he does understand that he's wrong, and he's now got this cognitive dissonance.
But I hope you're not just putting words into his mouth here about what actually happened.
Well, you asked. You remember you did ask him. I got you to. Well,
yeah, but I think what you're doing is you're answering like on a what may have happened and what didn't happen. People need to listen back to actually what actually happened,
Absolutely,
rather than you actually saying that you think you qualify that this is what actually happened.
Well, the point is, he did demonstrate that he had a little bit of understanding of my point when he was forced to answer your question that was repeating one that I did. And he did actually understand that the mass, for instance, of an apple is the same whether or not it's pulled apart into its component masses. The mass of the apple is the same as the masses of its component atoms, and he did seem to understand that, and he admitted to that. And I think if he possibly overnight, he might have a little revelation, then think, oh yeah, it's the same for the atmosphere, isn't it? The atmosphere is a single thing. The atmosphere, we talk about a single thing called the atmosphere, and that's why when you take some air away from it, you haven't got the atmosphere.
Yeah, but didn't you say that air is the atmosphere?
Yes, I know I said air is not the atmosphere, because there is only one atmosphere. If you take away a bit of it, there is only one atmosphere, so you can't have two of them. I mean, this is a philosophical point.
What about the air is the atmosphere? Come on, explain that.
Air is not the atmosphere.
I want you to qualify that point.
Right, okay, I'll say it again. The atmosphere is a single thing. You cannot if you take away a bit of the atmosphere, you haven't got the atmosphere. Just like when you go to a beach, for instance, and you take some sand away from the beach, you've got a bit of the beach, but you haven't got the beach. So, for instance, let's talk about Harlock Beach, for instance.
No, let's talk about the air and the atmosphere.
Yeah, I know, and I'm trying to explain.
No, I don't want to qualify it with other stuff. I want you to answer the question.
We
already know about your apple.
Understand my
we
point.
know about your apple. We've been through this. We don't want to now go on to sand and beaches.
If you let me explain it the way I explain it, it'll become much clearer for you. It'll be less confusing. If I were to ask you to go to a beach and then you brought back me some sand, then you would say I've got some sand that was part of the beach. Similarly, when you get air, if I go and get some air from there, so I put in a jar and I grab some air, that's not the atmosphere. That's a part of the atmosphere. It's got the same molecular constituency. Well, actually, it hasn't, because the atmosphere has got varied constituency.
So in that case, it's not masses, it's not mass.
What isn't?
Well, if you're saying that air is not the atmosphere, essentially, you know, if you do it into its component parts, masses versus mass, you know, essentially you've taken some of the masses out of the mass, so you have both.
Right.
So air is the atmosphere.
No, it's not the atmosphere.
It is. Absolutely, by your own volition.
Let's try again, Ranty. You didn't understand.
No. I did understand very well.
Let's try again.
I understood very well. Thank you very much.
Anthony, Ranty, if I take a jar of air, have I got the atmosphere?
If you take the air out of the atmosphere, you have taken masses out of the mass.
But I haven't got the atmosphere, have I?
You have taken. Wait a minute.
I've got a bit of the atmosphere, which is not the same thing as the atmosphere.
You've taken.
Listen, Ranty, just try and listen.
You've taken
please
masses out of the mass.
Right, Ranty, please try and concentrate. There is only one atmosphere. The air is a component of the atmosphere. So if I take away some air in a jar, I haven't got the atmosphere. That's the singular atmosphere. I've got a bit of the atmosphere. So it's not the same. Air is not the same as the atmosphere. The atmosphere is a singular thing. This is basic logic. I've got a bit of air, I've got a bit of the molecular constituents of the atmosphere, but I haven't got the atmosphere. Just like when I go to Harlech Beach and I grab some sand, I haven't got the beach, I've got a bit of the beach, I've got some sand from the beach. So the sand is not the same as the beach, therefore air is not the same as the atmosphere. It's really, really simple.
Yeah, you're going to just have to bear with me here, because everything seems to have crashed for some reason. No idea why. Hang on.
I mean, it's just basic logic. I mean, this is if you do some basic logic, research into logic, you'll understand the concept of singular things, component things, one thing being equivalent to another or not the same. And I mean, this should be obvious to anybody with a brain and an IQ, I don't know, above 100, really. If you cannot understand the explanation I've given to you, then your IQ must be below 100, I suspect, or something like that.
Well, having been going for over 3 hours, I think I'm going to have to end this stream now. So Sleeping Warrior hasn't been able to stay till the end. The Roundtable 26 atmospheric pressure does not exist. Is now concluded. The Rumpus, would you like to sort of end this, seeing as Sleeping Warrior isn't here?
Okay, well, I'm a bit shocked at how stupid Ranty is. And I know he's not very bright, but he's really reached a new low here. I don't think he's been as this stupid. There's probably one occasion he was similarly stupid. But I was happy to go on to talk about how pressure, how you determine calculations of pressure and things. But unfortunately, when you're faced with someone who basically was very, very reluctant, I think he did in the end accept that the mass of an apple is the same as the sum of the masses of the apple, and then start to get all confused by English, which he does get confused by English and comprehending it. We didn't really get to the actual what could have been vaguely interesting. Instead, I'm too busy educating Anthony for the education he should have had when he was about 12, unfortunately, to put the point before we can discuss things when he would have understood things about when he was the age of 15. We're still at the age of 11 or 12 with him, unfortunately, and in some cases even worse. Yes, he's got a lot to learn, and the fact that he suffers from Dunning-Kruger and thinks he can lecture other people. I mean, people like Blue Marble Science, who's infinitely more intelligent than he is, to have him lecturing Blue Marble Science about things when he has no understanding of science at all and doesn't even seem to understand the collective noun and masses of everything, and he doesn't seem to understand the philosophical point that everything we see around us is a collection of something else. So even an atom is not a single thing, it's a collection of quarks and electrons, and even there's some suspicions that quarks are a collection of things as well. So everything, and almost everything you encounter in the real world, is a collection of something else. So we're always talking about collective terms for single things.
Okay, well seeing as Sleeping Warrior isn't here to...
He's in the chat.
Okay, well, seeing as he isn't actually here to respond in voice, I'm going to end this stream, and I need to thank Sleeping Warrior actually for doing a good 3 hours on this show, holding his own essentially. Whether or not you agree or you disagree, you can make that mind. You can make your own mind up on that. For me personally, you know, I mean, I'm not going to get involved as normal. Roundtable 26 is now finished, and I will see you all in the next one.